My name is Emil Olsen.
And I'm John Christoph Knudsen. And we're live here from a studio here in London, the centre of London, at Westminster Bridge.
County Hall, the centre of London by Westminster Bridge, the heart of London, really. Why here, John Christoph?
Well, County Hall has, 67 years of hosting the London government. It is the place to be when it comes to be closer to politicians. It is the place to be when it comes to be close to partners, to our customers, and of course, what we're really looking forward to later on this year is to opening an office here at County Hall.
We certainly look forward to that, but also before that, we today have a full program spec with distinguished guests from Man Energy, from Carbfix, and of course, our own technology experts from Aker Carbon Capture. And we'll take you through all this here from the green room here in London. So, Jon Kristoffer, what do you look the most forward to in this quality program?
Well, I think it's very hard to, for us, technology today is of course about the technology, but it's also about our core values, working together, bringing our partners through. We have Man Energy, we have Carbfix, exciting things coming on, but it's also about bringing that bold innovation. What is the next generation products that we're bringing to the market, and how will that influence our customers? So we have a lot of things to look forward to.
Indeed. And so today, now in a couple of minutes, the room is filling up. You can hear the bus going on. So in a few minutes, our CEO of the company, Valborg Lundegaard, and our head of UK and head of investor relations, David Phillips, will welcome you all and start off this technology day from Aker Carbon Capture. Stay tuned and looking forward to carry you through this day.
Good afternoon, everyone. Huge welcome to everyone who's turned up for our first Technology Day with Aker Carbon Capture. It's set in London in person. It's wonderful to see back to one form of real life at least. We have over 100 here in person, fantastic. We have over 700 online. I guess that's nice when you have a US-friendly time zone, just saying where some friends might be as well. I'm David Phillips, I'm head of the UK and Investor Relations. And I'm delighted to be joined by a wide range of technical specialists today. We have some key partners from Man Energy, from Carbfix, and of course a long list of the top Hollywood cast from Aker Carbon Capture itself. A lot of key technology players, key engineers, and so on. We have a lot to go through today. Actually, I should point out our setup here. We actually are quite close in the same building, just about, with our new London office. So this is really going to be our heart in the UK as well. And it's great to see all of our UK team here in person. And I hope we have plenty of time later on to interact with networking later on. One quick housekeeping comment. There are no fire alarms planned. Those of you who were here a little bit earlier would have noticed the fire alarm works because it's been going off for half the morning. But I can guarantee you, as they always say, if you do hear an alarm, just follow us because we've heard it, we know what it sounds like, and if we run through that door or that door, just follow us. We also have a lot of online content. So everyone who's joining us online has been watching a bit of a special show already. There is a green room which you can join, which you can also have Q&A answered. There's an online Q&A function. You can join this in the coffee break. Look at also, and I'll remind you again later, but when we get to the networking reception, there's also room for that as well to go through some Q&A and to hear some more special content afterwards. So we're going to have a quick, I'm not going to go through the agenda. Hopefully you'll be able to look at this on your online phone, on your online app already. But we're going to have a pretty packed agenda, and it's going to be quite a challenge to keep on schedule. But as we are between, we know you've all had lunch, so maybe that initial stress is not so great. But we know we stand 2 hours between you and now, or 3 hours between you and now the networking reception. So we're going to have a short intro with myself and our Chief Executive Officer, Valborg Lønnegaard, just now. Then we will run through the schedule, and really looking forward to your participation as well. So Valborg, would you like to join me for a few minutes?
Thank you, David.
So, Valborg, we're, as a company, 2.5 years old. You've had the top job for 2.5 years. Yes. Clearly, we've done a lot in that time. We are building the first 2 industrial plants in Europe, with Twence in the Netherlands, Brevik CCS in Norway, and so on. Clearly, there's a very strong technology story. But what does technology mean to you in carbon capture?
Well, of course, I'm a chemical engineer, so I can dive directly into the solvent. We have unique solvents in our post-combustion amine technology. The process design is fantastic with heat integration, but I have to admit, even as a chemical engineer, it's so much more than that. It's also the modularization and standardization that we've implemented into our products, which drives down cost. And now I see going forward, the digitalization being even more important. But looking even beyond that, I would say I'm a technology freak, or I think we all appreciate how technology has improved our lives. And energy is an important part of that. But sometimes when we implement new technology, we don't see the risk. And one consequence of implementing new technology we see now, and that is global warming. But what you really can say about the carbon capture technology, it is man-made technology for carbon capture that can mitigate and fight global warming, man-made global warming.
Absolutely, man-made global warming, and we're fighting it with man-made technology.
Yes.
Absolutely. Is there one part of the technology story, envelope, themes that you think maybe is underappreciated?
Well, there has been a lot of attention of our groundbreaking Brevik CCS project, the first carbon capture project on a cement facility in the world. But I am equally proud of the Just Catch offering we are delivering to Twence in the Netherlands. And this is a modularized, standardized offering. And we can deliver this so cost efficiently and within 2 years. And I certainly believe that the market for Just Catch going forward is going to be huge. Because when we have all these infrastructure in place with hubs, with transportation and storage. There are a number of medium-sized emitters around these major hubs that would like to implement the Just Catch. So I see a big market expectation for this one. And also, I actually see Just Catch as a role model for our bigger plants, because the principles that we have implemented to reduce the cost of carbon capture will be implemented also for larger plants. Modularization, standardization, digitalization.
Absolutely. Now, this industry is still quite young in terms of really being, really hitting scale.
Yeah.
But it's not just a case of one company against the other. It's a big theme of partnership, isn't there?
Oh, yeah, absolutely. And there is no way that we can achieve our targets alone as a company. We can contribute. We are lucky. We have the technology and we can make a difference. But we need to work with partners. And we have good examples of this here today. You can see the importance of partnership. We have actually invited 2 of our key partners to present here at the event. And that shows how important it is.
Absolutely, absolutely. Well, thank you very much, Valborg. Thank you.
Thank you, David.
So, straight on with the schedule, and the partnership comment was deliberate because the next speaker, Uwe Lauber from Man Energy, is one of our key partners. So, Uwe, really over to you.
So, thank you very much, David. Thank you, Valborg, for the introduction word. And I like your statement, carbon capture is a man-made technology. It's an MAN-made technology. So thank you for that. But having said that, it clearly shows also that this word shows that we are working together. We need partners. We need partnership. We cannot change the world by ourselves. Whether we like it or not, we have to think about how to do it fast. And this is what we have done 5-6 years ago already, when my company, our company, was called MAN Diesel and Turbo. We thought about it, what do we do in the future? I mean, Rudolf Diesel has invented this nice engine, so to say. We should all be proud about that. An engine which generates energy, which helped us to bring the world where we are today. But negative side was, of course, emissions. So today, the company is called MAN Energy Solutions. So we thought about what is our purpose for the future? What do we have to do? What drives our business? And also, Valborg has mentioned that digitalization and decarbonization are the main driver. And having said that, I made my life easy. I want to start this short presentation to show you what we really are, what our purpose is in the future, but nobody should forget about the past, history. So future needs also origin. And I think now I would like to start with our purpose movie.
What matters in the fight against climate change? Bringing 90% of global commercial transport emissions to zero? Or picking up this little bottle? Heating big cities all over the planet? Or riding a bike to the office, rain or shine? Rolling out green hydrogen to replace fossil energy sources, or risking a few goosebumps each day. If billions of people take care of the small things, we have the obligation to deal with the big things, because we can. We have the experience and the technology to decarbonize sectors that matter most. Moving big things to zero, so that the small things matter too.
So, Thank you for that. So moving big things to zero, that is our new strategy, that is our new slogan. That means we want to help our customers to decarbonize their business. How we're going to do that, I'm going to show you later on, but you should be also aware, and you saw it also in this movie here, everybody can make a contribution to decarbonize the world here. Like the little boxes, like riding a bike to the office or whatever it is. So think about it. Do we really need 22 or 23 degrees C in the room here, or 1 degree C lower? These are the small things. So everybody can make a contribution. But we take care of the big things. And the big things you can see here. These are our main pillars for our future growth. And I want to start on the left side. You see heat pumps. You have also seen one, obviously, I think you have not realized that it was a large heat pump. The smallest heat pump which we have in our portfolio starts with 10 megawatt. So it's not the small heat pumps you're going to have maybe in your household. These are the big things. And we want to help our customers like BASF, industrial sector, where a lot of heat is required. 2/3 of the energy is needed to produce heat in chemical areas, in process applications and so forth. And 1/3 is needed to produce heat, to heat up our households. A good example is just in an implementation phase in Esbjerg, is roundabout a project where we replace a coal-fired power plant, because coal is used to produce heat, and this heat is then used to heat up households in the order of magnitude 20,000 households, roughly. 60,000 tons of CO2 will be avoided via installing this heat pump. You may ask the question, okay, heat pump is nice, but how is it driven? It's electricity. We need electricity, that's quite clear. And we need to ramp up as human beings as much as possible renewable energy sources, because that is the key driver here. With BASF, we have signed also an agreement to replace a gas-fired heat production, because there in Ludwigshafen a lot of heat is required to drive their process. Also there, this is still under investigation, but I'm quite sure it will be materialized. This will be the biggest heat pump in the world, avoiding 450,000 or 500,000 tons of CO2 being emitted every year. 500,000 tons, just for you, to give you a feeling, means 250,000 cars equivalent, just to see how huge these things are. That's why we say we want to move big things down to zero, down to net zero. And Walborg and I, we have been also at the COP this year in Egypt to feel the spirit that was really emotional. Now the time is over that the society, that we as human beings only talk about certain things. We need to act. Although, I have to say, my personal view, and I think you share it as well, the 1.5 degrees C target, which has been defined at the Paris Climate Conference a couple of years ago, we will not meet it. And that should underline again that time is over. I have 2 boys. They are 21-year-olds, the older one, and the younger one is 18. My obligation is, as a CEO of the company, to also show them that we are doing something that it's worthwhile, that they have an environment, that they can live in a nice environment. I'm coming from the Black Forest. When I was growing up, we had 2 meters snow. No problems. Today, this year was extreme. January, Christmas time, 12 degrees C, 14 degrees C, unbelievable. So I think the last person should think twice. Now we need to act, and now we need to react. And one vehicle is heat pumps. The other one, and this is why we are teaming up, and it's a great story with Aker, and it's not that we have started 2.5 years ago. This tradition of collaboration is key, and it started a couple of years ago already when we did traditionally the business in the oil and gas sector, of course, yes, okay, nothing against it, but we develop now systems, solutions to decarbonize sector, and CO2 plays a significant role. There are certainly some areas, some processes where it's unavoidable that CO2 is there, like the cement industry. Cement industry is responsible for 8% of the emissions. 8%. The whole society is talking about our mother company, Volkswagen. Cars. Cars are the enemies. Maybe it's not. Maybe it's not. There are other areas, like the cement industry or our other customers, the big things, the ships. 3% of the global CO2 emissions are responsible because of the shipping industry. So these are our customers. And our task and our duty really is to help them, to support them, that they still can do their business, but in a decarbonized way. We have here developed, I think, together as a team, a system which is unique. With our compression system, we are in a position to take out the CO2 out of the cement process on one side, but on the other side also to feed back the heat, because if you compress the CO2, you're going to generate also heat, temperature, and this one we're going to bring back. And at the same time, of course, the power consumption of the whole plant can be optimized. Hydrogen, you see here on the right side, electrolysis. We have invested a couple of years ago in a small startup company because we strongly believed hydrogen will play a major role in this decarbonized world. And I hope you all agree that this is one of the bases. But again here, where does it come from? It needs to be green as well, hydrogen. Yeah? But we need to do it also stepwise. I have nothing against blue hydrogen coming out of methane. And what a surprise, CH4C, okay, we split it. Here carbon capture comes again. So hydrogen and CO2 or carbon capture goes hand in hand. And that's a must. And people need to understand that, and specifically politicians need to understand that. I'm really happy, I'm German, that our economy minister, Mr. Habeck, has visited, I think it was last week, Brevik, that plant. So also Germany slowly but gradually understands the necessity of CCS. By law, by the way, it's forbidden. It's still forbidden to do CCS, but this will change. And this is a fundamental change which is definitely necessary. So also here with these electrolyzer units, we can produce hydrogen. And the quantity, the volume of hydrogen which is needed, it's tremendously high. So we want to build as a company, together with partners, not only, but together with partners, we want to build hydrogen plants. Not only these small things. We are talking about hydrogen plants, 50 megawatt, 100, 200 megawatt, maybe 1 gigawatt. Again, we need electricity. Hydrogen production itself is not a business which we can do alone, because electricity, or we have to generate electricity where it is cheap. In the Sun Belt, for instance, like the Middle East, in Saudi Arabia right now, on Saturday, there's a huge conference there. They plan a plant, a solar power plant, for 1.6 gigawatt. I hope it will be realized. This plant solely is there to produce hydrogen, which is the basis for all synthetic fuels, whether it's synthetic methane, whether it's e-methanol or ammonia, it doesn't matter. Hydrogen plays a key role, and we need to build that infrastructure up. That brings me to the third and the fourth point, or fifth point, let's say. You see here the ships. These are our main customers. 50% of the world's trade is being made with our engines. A container vessel is in operation more than 30 years, even 40 years sometimes. So our customers are asking us, hey, what solution can you offer that we decarbonize also these engines? And this can only be done via the decarbonization of the fuel. It's not done with a battery, for instance. Such a vessel like this one has 20,000 containers on it. The operator does not want to transport batteries from left to right. He wants to transport our goods, right? And even if he would do that with a battery, the battery pack would be so huge, there's no more space to put on a container. So this is, from a technical perspective, it's not possible. So therefore, decarbonization of the fuel, which means synthetic methane, for instance, because it's still available. And we did it, and we demonstrated it to the world. 2 years ago already, there was a customer prepared to make a change on the engine from a, let's say, heavy fuel oil driven engine. We converted it to a gas engine, pure methane engine, and this gas engine has been blended with synthetic methane coming out of a plant, Power-to-X plant in Werlte in the north part of Germany, which we have built as well. So, at the time when we had this event, I was really frustrated. Why? Because there was an audience like this one, a lot of journalists were there, and one journalist asked the good but stupid question, good and stupid, they are not, no, that was a good question. He said, what is the difference between fossil methane and synthetic methane? There's no difference. It's even better, synthetic methane. It's CH4, it's pure CH4. And you see methane, C, carbon, H, hydrogen. That's it, that's it, that's it. So we need both. And carbon will be a product for the future, which we also need to produce synthetic fuels. Definitely it will be a product, and it will have a cost, I'm quite sure. So on this shipping environment, on the business itself, we also have to have a solution for the existing fleet. Because imagine 20 years, there are around about 25,000 ships in operation being equipped with our engines only. And they will be in operation for the next 20 years. So also there must be a solution. Solution means for us, we're going to do a kind of a retrofit. We convert the engine to make them available or so that they can use these alternative fuels. But please remember, the basis is hydrogen. We need to ramp it up, and that takes time. Maybe until 2030, I'm not quite sure, but we need to speed it up. Otherwise, we will not achieve the 1.5 degree C target as agreed in the Paris Climate Conference. We have all what is really necessary on this chain value, so to say. We bring all together, but again, you see on the left side, whether it's thermal energy, whether it's wind energy, whether it's solar power, doesn't matter. Renewable energy source is the key driver to produce via electrolysis, which we have in our portfolio as well. You see down there, to produce hydrogen and then bring hydrogen together via our reactor system, methanization, for instance, which will be produced also with us. And you see in the center a Power-to-X plant, which we built as well, small and large ones, in order to serve the certain markets. Of course, all kind of gases needs to be compressed, whether it's CO2 or hydrogen or whatever it is. Also, this is in our portfolio. That's why I strongly believe, or why we believe, teaming up makes really sense. Clearly defining what are the boundary layers where you guys are good, Aker Solution is good in, and where we are good in, and teaming up, that's a strong partnership. That's a strong partnership, yeah. And at the end of the day, you see here, even our engines as of today are already 20% hydrogen ready, can be used. I personally believe that burning hydrogen itself doesn't make any sense at all, or not that much sense, because the energy content is quite low. So it has to be transformed in a kind of a carrier, whether it's ammonia or methanol, we will see. But again, let's do it stepwise. First thing is we need to have hydrogen. That's key. That's the key. Hydrogen on one side, and just remember what I said right at the beginning. Hydrogen alone, no. CO2, we need to team it up again. And that CO2, carbon capture, okay, yes, it comes out of a cement industry, it comes out of an industry sector, but this needs to be used again, carbon capture and utilization, that's really one of the key driver as well. So on a long term, this slide I have shown at the management conference of MAN Energy Solution last year, and thank you for your contribution as well. Aker was also there and has presented their strategy, and what a surprise, that goes together. And we thought about how does the company look like in 2030, so these figures with the products which I've shown you on the left side, you see it here. What is the contribution in terms of CO2? And our equipment may abate round about 10%, 10%. So our small company, 10% with the equipment. That is the motivation then for our people, for our team to say, in the evening when you go home with your family, I said, look, I gonna do something. I gonna do something. And that also drives me, pushes me out of early in the morning, out of bed, and say, hey, let's do something. Please don't talk, we should do and act. You see, retrofits and the green engines here, 0.5 gigatons per year will be avoided. That's around about 2%, considering a global emission of around about 30 gigatons or 35. It depends which study you believe, but around about 30 gigatons is the basis. CCS, quite high, 5% with our compression technology. I think Breivik is avoiding 500,000, 400,000 tons on an annual basis. 400,000 tons, only one plant, only one cement plant. How many cement plants do we have in the world? Guess? 2,000? Even more, I guess. Yeah. Yeah. So it's a huge potential. It's a huge potential in terms of emission reduction, but also, and I mean, I'm here as a CEO, we have to make money. For us, it's also a business opportunity. And again, I'm really proud that we have such a strong partner like Aker here. And together as a team, we act, we do. And the examples you heard from Walborg already, they are real examples. That's not a dream. It will come. Definitely it will come. Heat pumps, that was also one part which we discussed this morning together. Another opportunity, because addressing industry sectors with CCS, with processes where you have to take out the CO2, most of the time, what a surprise, these industry sectors needs heat. So why not teaming up there as well and do something together? So there are a lot of opportunities together which we can do. As I said before, also, H2, hydrogen, plays a key role. So sum it up, 10% until 2030 can we as a company, can we avoid? And that is really a great story for a company with a history we had, coming from the diesel world, so to say, yeah? Now moving to a decarbonization champion. And that was also the slogan. Jim, I think you remember that. We defined us and we said we want to build out of MAN Energy Solutions the decarb champion. Not alone, together with partners, that's quite clear. So, again, green energy is a key topic. Again, on the left side, you see here renewable energy sources. Solar, wind, doesn't matter, but also CO2. We are working with Porsche on a project, unfortunately not mentioned in the press for whatever reasons. I do not tell you that why this is the case. Electrolyzers, it's a project in Chile, maybe you have seen that already. And Porsche strongly believes that also the 911 will stay in place for a long time. Yeah. Whoever owns a Porsche, he is not driving most of the time that often, but the car is in operation more than 45 or 48 years. That's according to their statistics. So it's not like an ordinary car which will be scrapped after 10 years. No, that's not the case. So they have the same opinion. They need to give the driver of a Porsche the good feeling that he's doing something also for the climate, yeah. And the idea there is to use e-methanol. And to produce e-methanol, you need electricity first to generate via electrolysis. You need to produce hydrogen. And then, of course, you need CO2. This CO2 comes out of the air. From a technical perspective, very, very, very difficult to do so. But they do it in a prototype phase, and let's see. We are delivering or have delivered the methanol reactor already, and it produces e-methanol, which can be filled in to a, let's say, a car. So also here, it's a closed loop. CO2, hydrogen is needed, and that's why we strongly believe that this is a business for us both. Heat pumps, that's an example which I've mentioned before, being installed. These are the huge beasts, 2 times 15 megawatt of power which is being generated. And down there, just before Christmas time, we have also signed a memorandum of understanding with a company called Fonterra. I haven't heard anything about that one, but they produce milk powder. And milk powder, you can imagine, you need a lot of heat. They have 20 plants all around the globe, and therefore they have in their strategy clearly defined until 2030 they want to avoid the heat production being made with fossil fuels with a heat pump. So good example as well, and that brings me to the end. So I hope you understand why we are together, why we are both together, both companies, because with a strong partnership, we still have in mind the 1.5 degrees C target. As I said before, difficult to achieve these days, but we should not give up, but we need to team up. So thank you very much. Thank you.
Dr. Lauber, thank you so much for a very clear and powerful presentation. MAN-made solutions to climate change. I like it. Next up, delighted to introduce our own CTO, Chief Technology Officer, Jim Stian Olsen. Over to you.
Thank you. Thank you. The theme of our Technology Day is carbon capture and energy. And I will share some thoughts around how we view that, both on a high level, what does it mean, and also how do we approach it as a company. And I'd like to start with this number, 36.3 billion tons of CO2 that we humans emit every year. And our goal is to reduce this number to 0, and we have to do this in a quite short time. This number is the reason we're here today. This number is the reason that Aker Carbon Capture exists, and it also drives a lot of the decisions that Uwe alluded to in his presentation. In Aker Carbon Capture, we believe in the chain of thought that says you should start with the low-hanging fruits. If you can optimize your process so it uses less energy, you should do that first. If you can replace fossil energy sources with renewable energy, you should do that second. But if we can learn anything from the history of energy transition, it's 2 things. One, it takes a lot of time. On average, energy transition from one primary energy source to another takes about 1 to 2 generations to do. And secondly, since humanity switched from biofuel back in the 1600s, when you started using coal at scale here in the UK, no primary energy source has been covered more than 50% of the energy demand of the world. So that's sort of the largest thing we've seen. And that tells us that in the foreseeable future, there's going to be fossil energy sources part of the energy mix that we have in the world. And secondly, we have an industry where CO2 is an inherent byproduct of the processes that it uses. So there is also CO2 that we need to capture. And this is the reason why carbon capture becomes a very important element when we're going to reach 0 from that large number from before. And in Aker Carbon Capture, we are a post-combustion capture technology company. So we've done some calculations on the back of an envelope and trying to understand what does this big number mean to us and our industry. And we believe that by 2030, we need to have a capture and storage capacity of approximately 1.4 billion tons of CO2 every year. And by 2050, that number will increase to 4.2 billion tons of CO2 captured and stored every year. Carbon capture is an energy-intensive process. So what does this mean from an energy perspective? If we were to take a non-proprietary carbon capture technology off the shelf and deploy it to solve this problem, the energy demand that we need to drive that carbon capture process on a global scale would be similar to approximately 1.5 of the Norwegian gas export today. In 2050, the energy demand will be approximately the same as 3 times the energy demand of the UK today. So it's clear that if we're going to deploy carbon capture at scale, energy optimization has to be at the forefront of our thoughts and the solutions that we develop. In Aker Carbon Capture, we have a proven and patented technology. We've been doing it for a long time. We deliver good performance for many industries with our technology. In addition, we have a very strong focus on getting a very good HSE profile on our technology, so that when we deploy our technology on our plant, it doesn't harm the environment locally. So that's very important for us. In addition, we have more than 50,000 hours of operational experience with our technology across a variety of industrial sources. And this shows us that the technology works, and we can use it in many, many industries. I know a lot of you probably know a lot about carbon capture, but I thought I'd take the opportunity for those who maybe don't to share a little bit how it works on a high level. On the left-hand side here, you see our emitter. They have a combustion process which creates a flue gas with CO2. We take that flue gas, introduce it into our absorber tower. This is usually a stack that is 40, 50 meters high. And at the top of this stack, we introduce our solvent. That's the chemical that separates out the CO2 from the flue gas. It flows in a countercurrent flow, capturing the CO2 on the way down. And then we pump it over to the desorber, where we introduce heat in the form of steam. And here we heat up the solvent so the CO2 is released before we collect it at the top and take it to our compression and liquefaction plant for transport and storage. The carbon capture process primarily requires thermal energy. And here you see a typical case where we haven't done any heat integration or advanced energy optimization. We still have compressors, and we have heat exchangers, and we have pumps which require electricity. So on a normal plant, about 22% of the energy demand is for electricity. 78% is for thermal energy. And this thermal energy we can extract from the plant itself or from any other steam source available nearby. But then, of course, we want to reduce this number. So we have developed a technology we call the energy saver. This technology allows us to harvest some of the waste heat that we have from our internal process. And then we add a little bit of electricity. So now the electricity consumption goes from 22% to 25%. But the overall total energy demand is reduced by 10%. So now we have achieved a little bit improvement. Then, together with MAN, we have developed a solution where we can harvest some of the waste heat from the compressor train. Then we have to add a little bit more electricity. So now the electricity consumption increases to 35%, and the thermal energy demand is 65%. But the total energy demand is reduced by 20%. So now we're sort of getting somewhere. And then we see that in addition to optimizing our internal processes, we also see that by working very closely with our customers, we're able to develop good solutions that give even better techno-economic optimizations. For example, we have customers who have a lot of waste heat. So we can develop solutions where we harvest all that waste heat. So with a little bit of investment upfront, we're able to secure free energy to the capture process throughout the lifetime of the plant. And then some of our customers don't have a lot of waste heat, and maybe they don't have access to steam either. And then we have to use electricity as the driver, and we can use heat pumps as a solution to drive the carbon capture process. And then, of course, in some situations, which we'll see examples of later today, we have a hybrid solution where we combine all of these and get the best possible solution for our customers. And all of these ideas look very good on paper. But I think one thing I want to emphasize is that this is not just on paper. we're delivering these solutions today. For our customer Norcem at the Brevik CCS project, we harvest their waste heat so that we can drive the process. We are implementing the heat integration with our compressors together with MAN. So this is being built today. So I just want to end my presentation with a little hope. I hope that you get to learn something today, because we definitely want you to learn a little thing or two about energy and carbon capture. And I also hope that you are a little bit inspired by what you're going to see here today. And most of all, I hope you enjoy the day and you get to talk to a lot of people and have a good fun. Thank you for your attention.
Thank you. Thank you, Jim Stian. Okay, now we have a slight diversion away from the heavy engineering, and we're going to the world of data science and information technology, where the data world might meet CO2. So, Simen Ringdal, over to you.
Thank you very much, David, for that introduction, and good afternoon. It's nice to see people here again. My name is Simen Ringdal, and I work as a data scientist in Aker Carbon Capture, which basically means that I work with computers and statistics and numbers, lots of numbers. And I want to talk to you today about how data science can make a difference in carbon capture. Now, some of you may have heard about data science before, but some of you may not have heard about data science before either, and I don't blame you, because data science really hasn't been that prominent of a term in carbon capture, at least not yet. And if you have heard about data science, I can only apologize, because we have a tendency to use the buzzwords, don't we? Especially if you include my friends in digitalization, we tend to use exaggerations like AR, VR, blockchain, hyperautomation, quantum computing, those sorts of things. And I'm very much guilty about this myself. When I try to summarize what data science is, the best phrase I could come up with was that data science is a tool that enables us to efficiently understand data from multiple sources to make smarter data-driven decisions. This is a mouthful. So for today, I want to take a step back, away from the buzzwords, and really tell you how we are using data science in ACC today, both where we are today and also where we're going in the future. We need to understand that when we have a carbon capture plant in operations, there are a few things we need to get right. We need to reduce our energy consumption, which is the theme for today's event. We need to get our solvent consumption right, solvent management right, so we have a solvent at its maximum capacity. And we have to reduce maintenance, almost to the point that we can predict when we need to fix stuff before they fail. Now, all these three have in common that data science can help them out, because all of these three have in common that we need data in order to understand them. Now, data is something you get from a carbon capture plant which is running and in operations, and we don't have that many carbon capture plants running right now in the ACC, but we do have one significant one. This is the MTU, the Mobile Test Unit, and you'll hear a lot more about the MTU throughout the day. But what I want you to know for now is that this is a mobile capture plant that has traveled around the world, currently here pictured in Mo i Rana. And this has about 200 sensors distributed across the carbon capture plant. That's like a gold mine to me, because these pump out data every second. And perhaps the best way of explaining what my job is that I take these sensors, the numbers coming from the carbon capture plant, and give more context and more value to it so that it's more useful for the operators and the engineers. I'll give an example. This is a number taken from the MTU, one sensor value. This is usually what I'm presented with. There's a number coming from some sensor without any context at all. I can help you out. I can add a unit to it. So you see that this is measured in percent, some sort of percentage value. And I can even add a title. So you see that this is a CO2 concentration in the flue gas entering the mobile test unit. Now, this is not fake data. This is real-life data taken from a previous campaign, but I've sped it up so that every second you see on screen is 1 minute in reality. Now, often this will suffice. An operator may come to me and say, hey, could I please get this number presented on the screen? I want to know how much CO2 concentration is in the flue gas. But sometimes they might ask me to put the number up on some sort of number line so they can see how it relates to the other concentrations as well. Or some of them might ask even to have an historical trend so they can go back in time and see what the concentration was in the past compared to the current to make good decisions for the future. So then we get an historical trend. Now, all of this is the same sensor. I've only added more representation and more context to it. It's very cute to see you all following that green dot. You're like small kittens following your screen. Very good. Now, this is what I like to call level 1, raw sensor data. There's only one sensor coming in. So what happens when we have multiple sensors working together? Well, here's an example of that. 4 different concentrations of the flue gas coming in and out of the MTU. I might ask a subject matter expert, for example, Ricardo, who you'll meet later, what is the carbon capture rate? What is the formula for that? And I'll put in the numbers into the equation. And now what this gives us is a new metric on how we can run the carbon capture plant, because now suddenly the operators no longer have to follow the 4 different concentrations individually, but instead the one metric and run the MTU accordingly to, for example, here, hit the 90% capture rate as they were aiming for. And I think the operator did a pretty good job there. This is what I like to call a level 2 processed values, where we have some sort of mathematical operations placed on the numbers. So can we add even more context to this? Well, of course we can. Let's throw in a 3D model. This is the point where people usually call it a digital twin. This is a 3D model of the MTU uploaded in a program called Cognite Remote, which incidentally runs on the same 3D engine as Minecraft. So I was kind of pre-trained before I went to the ACC without really knowing it. But this tool is pretty good because I can slice the MTU in half and have a look inside it. And when we do that, and this model is also contextualized, and what this means is that all the different parts are clickable to the extent that I can click, for example, the blower, and see that someone has uploaded a picture of the same blower. So I can have fun clicking around on this model, or I can search for a particular asset. For example, here I'll search for the reboiler, a very important part of any capture plant, as you will hear later. And I see that someone has uploaded the PNID of the same reboiler, but also all the sensor data related to the same asset. Now, this is very useful for someone like me who is not too familiar with a capture plant, but I still want to understand where the data is taken from, so I can see that this sensor value actually belongs to this place. In this case, the reboiler power consumption, how much power the reboiler is using. Now, what about geophysical data? What about the data that surrounds the MTU? Well, here's an example of that, of a site where the MTU hasn't been, but we still wanted to understand what the MTU could look like on that site. I went to this site and brought with me a drone and flew over the area, taking many pictures, and I stitched these pictures together to become a 3D photogrammetry model. And I can move around using my Minecraft skills in this site, and I can do measurements that otherwise would be very hard to do without actually having the MTU at the site. Someone, for example, asked me, could I fit a forklift between this door and this wall? And I can do the measurements and say that yes, if your forklift happened to be narrower than 3.53 meters, you're good to go. We're doing the same for our twins project, which we've heard already something about, where we'll also get maintenance data from them. And it's very useful for our maintenance engineers to be able to place maintenance data from the past in relation to the asset, both in a 3D model and documentation and time series. Here, for example, we saw that someone made a pump inspection work order, and we can see this in conjunction with the other 3D model. So this is what I like to call level 3 combined process data. Now, this is all pretty cool, but up to now still pretty stupid, because it's not really giving us any more, just placing the same information, but much more organized. This changes when we go to level 4, where we have a decision-making tool. This is where the computer is smart enough to give us some sort of recommendation based on the data it has. Now, a good taste of this was something we got this past summer when we had summer students in a summer internship working for us. And they made a web application with one sole purpose, which was to determine the stability of a carbon capture plant. Now, this is not trivial, and in fact, they had to apply artificial intelligence to be able to determine what the stability was. They also provided a justification within the web application to say how it said it was stable or unstable. But it can also provide recommendations to the operators to say, this is how, based on past experience, you can make the capture plant even more stable. It will also send an alert to the operator saying that now it has reached a stable value, so they appropriately called the tool JustPling, just to keep it within the ACC lingo. I also mentioned in the start that we have maintenance that we have to reduce as far as possible. This is typically called condition monitoring, where we monitor a certain asset and try to figure out how it can see that it fails long before it does, or at least give an alert to the appropriate people when something goes wrong. On the MTU, we have pH meters placed around the MTU, and actually we have 3 pH meters placed on the same spot. Now, these should measure the same value, but of course, as sensors sometimes do, they will deviate, as we saw here in the previous campaign. What we can now do is that we can send an alert to the operator saying, hey, you have to go out and recalibrate the sensor. Much better to do that now than at the end of the campaign. We also have pumps, which should follow a designated pump curve, and if they deviate too much from that curve, we can again send an alert to the operators or maintenance engineers so that they can consider what to do. The same goes for heat exchangers that will lose in efficiency over time. We can track that efficiency, set a threshold, and alert the appropriate people when that threshold is reached. So this is level 4 decision-making tool. And I believe this is as far that we've come in ACC at the moment. So what's next? What are the next steps on this digital journey? What can we expect in the years to come? Well, firstly, we have a major advantage with the MTU, which is now 14 years old, I believe, and it's collected lots of operational data throughout that time. We can scavenge through this past data and look for good conditions in the past, learn from them, and apply it to the future. We also have people in ACC working with dynamic simulators, which will then be a good thermodynamic representation of a capture plant. We can then tweak settings on this simulator and get out the performance much faster than what we can do on a real-life carbon capture plant. We can also connect this to an optimization engine, which is a mathematical tool to find the optima of this model. And the two connected, we can say that please find the optimum settings so we can reduce the energy or reduce the solvent consumption or whatever it may be. Second to last, something that really excites me, because what happens when we have multiple capture plants out there? We can then do a cross-fleet analysis. We can take the learnings from one capture plant and apply it to the other. And lastly, autonomy. It's a long way there, but this is the northern star. This is what we're working towards. This is when we can lean back and say the computer's got it. We can sit and see it run all the capture plants we have across the globe. So this is what I like to call level 5, or an accurate capture plant model. But some of you will see I've reserved some space here at the very end, because after all, I am a data scientist, so I couldn't really help myself but to put up a question mark here and a few buzzwords. Because I don't know what's yet to come. AR, VR, blockchain, hyper-automation, quantum computing, I don't know. All I know is that it's really exciting. And in fact, I find it hard to conclude this session because I don't really know what the conclusion is. All I hope you're left with is that you have a better understanding on how all of this will enable us to efficiently understand data from multiple sources to make smarter data-driven decisions. And I invite you all to join us on this very exciting journey. Thank you very much.
Thank you, Simon. That was fantastic. I would not have guessed the word Minecraft would have appeared. I guess there would be some buzzwords, but not that one. But really exciting stuff. And actually, you mentioned a couple of interesting comments. We were part of a wider group, as you know, a larger industrial group in Norway, part of Aker. And under that umbrella, we do have some friends who know a lot about data science, as well as Simon. We have Cognite, A's, Aker BP, who's been a pioneer of using this type of technology on upstream oil and gas. So we have quite a big family to get some leverage with as well. Now, we've heard a lot about energy optimization in the talk so far. The next one is really focusing on energy optimization, full stop. I'm delighted to introduce one of our senior engineers, Monica Nicholson. Over to you.
Thank you, David, for that. So, we all want carbon capture to be a success, don't we? Yeah? Now, this is going to be a bit difficult if we need huge amounts of energy to run our carbon capture processes. So we work on getting that energy use as low as possible. So I work in the core technology group in ACC as an engineer trying to get our energy use down, and that happens to be what I'm here to talk about today. Backtracking a little bit though. Why do we even need energy to capture carbon? So our process is based on the absorption between our solvent and CO2. Now we don't really store the solvent, do we? We just store the CO2. So at some point we do need to split the two of these. And it is the splitting of these two that require large amounts of energy in the form of heat. So that's where most of the energy goes in. Now Wim Sian, he set the scene for us. He told us that using non-proprietary reference solvents means that in this case, for a typical cement production case, we would need as much as 3 times the amount of energy that the UK uses every year to reach our climate goals, which is a lot. So the question is, how can we do a bit better than this, or even a lot better? So having our own proprietary solvent, it's a start. It's a bit more efficient than reference solvents. But we can do even better than that by basing ourselves on this fundamental principle in physics, namely that energy is always conserved in any process. In other words, the energy that we put into a process also comes out of that same process. Lucky for us, very often that energy comes out in the form of heat that is just wasted to the atmosphere. And we can make use of that heat by collecting it and using it for our carbon capture process through different technologies for recovering waste heat. So, with basis in an example from an industry that you've already heard about today, using or being responsible for as much as 8% of the world's CO2 emissions, with basis in a carbon capture plant that captures CO2 from a cement production process, I will show you some of the ways in which we use waste heat recovery to reduce our energy use. So first of all, this cement process, it has some waste heat that we can leverage and use as energy input for our carbon capture process. Now, strictly speaking, we're not really using less energy in this case, are we? We're just making use of a source of energy that's really cheap. So in that way, we're able to significantly reduce the energy penalty of running our carbon capture process. Now that's great, although it's not enough for us to run our carbon capture process. We don't get enough energy from this. So how can we cover the remaining energy demand? We can make use of the waste heat coming from the carbon capture process itself. For example, I just told you that splitting our solvent in CO2 requires energy, right? Now the opposite, when the two of these are absorbed into each other, some energy is actually released. So that's an example of one place where we get waste heat that we can recover. A small disadvantage, this waste heat, it's at a lower temperature than we need to run our carbon capture process. But we can work around this. For example, by using the CO2 compression process as a way of upgrading the waste heat temperature. Secondly, we can use a heat pump to upgrade the waste heat, working in the same way as a heat pump in your home would work, taking heat from the outside at a low temperature, using some power to provide heat at a useful temperature. So our friends from MOM, they have solutions for this that you've heard about earlier today, which is great for us. Right, so those were some ways in which we can leverage waste heat to reduce the energy use. Now, how much energy can we save using these ways? Well, remember our reference solvent, MEA. which requires around 3.6 so-called gigajoules per ton of CO2 captured for a typical cement production process. 3 times the amount of energy we need. 3 times the amount of energy the UK uses every year, right, to reach our goals. We can do better than this. And if we leverage internal waste heat only, we are able to use a total of 1.6 gigajoules of power per ton of CO2 capture. I'm going to have a drink of water. Right, so you may notice this is heat and this is power. But remember, we're in a cement plant now. We're not using any waste heat recovery. How will we get this heat? So very typically, electric heating could be one of the only feasible alternatives that we have. And in that case, we can compare these two numbers on a similar basis. So you can clearly see that by using internal waste heat recovery, we can significantly reduce the energy that we need to capture CO2. Right, so that covers internal waste heat. What about external waste heat that we also learned that we can use? Well, if we have so much external heat that we can remove the heat pump, which is equivalent to what we will do at Norcem, actually, in this case, we can reduce the energy use compared to the previous case by 50%. So you can quite clearly see the benefit of being able to use external waste heat. So the takeaway from these examples is that through different ways of heat recovery, we are able to significantly reduce the energy that we need to capture carbon. Now we can put these two cases on a scale. So you see in the lower range, we need 0.8 gigajoules of power. In the higher range, we need 1.6 gigajoules of power to run our carbon capture process. We can see cases in between, of course, depending on how much waste heat we have. And of course, this is for this cement case. We can also see in other industries like metal industry that waste heat could be much more abundant. And of course, in that case, we can get this power consumption even lower down when we remove these ways of, when we no longer need internal waste heat recovery. So remember our baseline, MEA requiring 3.6. You can see that through different ways of recovering heat, we are able to reduce our energy use, which is what we were after in the first place. So yeah, to conclude. We wanted CCS to be a success, and we realized that we needed to use less energy to make this happen. You've seen that this is actually possible through different ways of waste heat recovery, and we're even in the process of supplying a plant today that uses these technologies for reducing energy use, and hopefully many more in the future. That summarizes my presentation. Thank you so much for the attention.
Thank you, Monica. Such an important topic. I believe also it's your first trip to London as well. And what better experience could you have than to give a presentation about energy optimization in carbon capture on your first visit? But anyway, very interesting stuff indeed. We're a little bit behind schedule due to the extremely high level of content in our slides and discussions. I suspect we're almost exactly 1/4 of an hour late, but I can't think of any better way to prepare you for a coffee break than to talk about our mobile test unit, MTU. So Ricardo Rundeli, over to you.
Thank you very much. Surprisingly enough, we are 2 minutes late, not a 1/4 hour late, which is good for me, so I can take my time. Hi everyone, my name is Ricardo Rundeli. I am a senior technology specialist in Aker carbon capture, and I have been working in core technology for 2 years now. But before that, since 10 years ago, I have been specializing myself in carbon capture technologies ever since I was a bachelor student back in Brazil. As a matter of fact, I moved from Brazil to Norway because I wanted to further my education and specialize more and more in post-combustion CO2 capture. And this biography dump is to say that that post-combustion carbon capture is not a novel technology. It's something that I knew about when I was a teenager. But it's only now that we are seeing a real chance of a large-scale deployment of carbon capture plants. Then the issue of validation, qualification, and innovation becomes more important than ever. If we need to see the deployment of a lot of carbon capture plants, we need to de-risk these deployments. And we have a tool that allows us to do that, and that's the Mobile Test Unit. So in this presentation, I'm going to give a short introduction to what the Mobile Test Unit is, and then I'm going to talk about how it's used for validation and qualification. There is a little bit of an interdependency there because we cannot validate what we have not qualified, and every process of qualification needs validation. But I'll try to break it apart, and then I'm going to talk about MTU and innovation. So let's start with a short introduction to the MTU, and we can take a look at the name, Mobile Test Unit. Mobile, that means that the MTU should be transportable. We can take the pilot plant from its industrial park in Heroia and take it to the sites of the end users, to the source emitters. And we can do that because the MTU is a container-based pilot plant. We have 7 containers. 2 of them are process containers with absorber, resorber, reboiler, etc. I think, Simon, you have shown a little bit of that. We have a reclaimer unit that we don't always use, but we can use if we need to qualify it. And we have 4 containers for transportation of equipment, chemicals, materials, tools, etc. And then you can ask me, okay, but if this, one step that I skipped, sorry. Ooh, okay, I'm close to the speakers. I'm not good at sound, sorry. Once we take these containers and assemble the Mobile Test Unit in with the source emitter, we have around 20 square meters of footprint, which is good for us because that means that we don't occupy too much of the plant. It's easy to squeeze in different industrial parks if we so need. But the question is, if this Mobile Test Unit is so compact, how can it give representative data for a real large-scale carbon capture plant? And that's because she's tall. We are talking about very tall columns, or columns that have heights representative of real-life applications. Our absorber, for example, in total it's about 38 meters height, 18 meters of absorber section, or packing, same packing that we use in our projects, 2 water washes, and the possibility of 1 acid wash. And likewise, the desorber is also representative of a real scale plant. Hence, the data generated with this plant is going to be representative of what we see in real applications because we have all the thermodynamic and hydraulic phenomena that we would expect to see in real life. And then now that we have this Mobile Test Unit, we can put it in a bag or in a ship or in a truck and move it around. Ever since the MTU was first built and commissioned in 2008, we have operated with natural gas-fired power plants in Tretavika, Norway, then coal-fired power plants in Longanet, Scotland, and NCCC, Alabama, United States. We went to Mongstad, to TCM, operating with the gas-fired turbine, but also with their residual catalytic cracker. By the way, it's interesting to notice that both the MTU and TCM were designed and commissioned at the same time, roughly the same time, following the guidelines of DNV for the building of pilot plants representative at scale. So they share the same DNA, so to speak. After that, we took the MTU to Breivik for treating a cement. That project was a success, and you all know the story. Now we have the Breivik CCS project that was hugely facilitated by the fact that we had a pilot plant campaign with that flue gas. We went to treat waste-to-energy gas in Klemetsrud, hydrogen in Prien, and I think Ryan, my colleague, is going to talk a little bit more about that, or a lot more about that. Then last year there was a treatment of flue gas from Char in Poland, and right now the MTU is in Mo i Rana, treating gas from ferrosilica. Later on in the year it's going to treat gas from limestone calcination. I was looking at the data from MTU today in the morning. We have a meeting every morning to talk about the new results. And that's because we have real-time data gathering. I'm not going to repeat ourselves. You did a marvelous presentation. I'm just going to add that not only we have all this information coming to our users in Oslo, Copenhagen, London, but we also have the possibility of remotely operate the mobile test unit, which it's good because it's safer in a way. You have less people on site, and you also makes the process cheaper. Right, so this is the mobile test unit. Now I'm going to talk a little bit about validation, qualification, innovation. Of course, when we go to a new campaign, we don't fly blind. We have an idea of what is the energy consumption, what are the parameters that we have to shift around, and that's because we have good modeling and simulation tools. But what we do is, if we do an M2 campaign, based on some information that we have provided beforehand to our clients in a feasibility study, then we can validate that we are giving credible information. Not only that, but several small process parameter modifications are gonna adjust capture rates, energy consumption, achieving an optimal. And with the mobile test unit, we have this possibility. We are there on site or in our computers in my hotel, and you can just shift things around a little bit and try to get the best performance. That hugely facilitates us to give the best options to our clients. Now, environmental impacts. Funny enough, the British Environmental Agency published 2 years ago, 1.5 years ago, the document regarding guidelines for best available techniques in carbon capture. And they specifically say that for emissions, for solvent degradation, one should have real representative data in either a flue gas of similar properties of the flue gas that one wants to treat in the large-scale plant, or the real flue gas itself. And the M2 was built for that. It allows for that. The reason for that is because if we can kind of guess or estimate the energy performance of the plant based on the CO2 concentration, the chemistry between the contaminants of the flue gas and the amine is a lot more complex. There are several small things that can happen, and treating a real flue gas is the best way to understand what are the environmental consequences of treating that particular source. For that matter, the MTU is equipped not only with all the sensors that we have spoken about, Stephen, but also with SEMS. If you don't know what SEMS is, it stands for Continuous Emission Monitoring System. In practice, for the MTU is an FTIR routing between several points, but there is a point on top of the absorber. So we know how much ammonia we are emitting, we know how much amines are coming out, aldehydes, etc., and we know how these emissions depends on operational parameters. And if that is not enough, we have the possibility of taking isokinetic samples. Now, I took this picture because for some reason I was volunteered to do this job for the MTU, which is to get into a crane and go to that height at 40 meters high. I'm afraid of heights, I hate it. But there you go, you go there, you take a sample, and once you take a sample of these contaminants that are so difficult to quantify because they are in the ppb level, parts per billion, it's easier. You absorb them directly, you take them to a lab, and you analyze for them. I would say coupling this thing plus our track record in all different flue gas sources, all different industry sectors that I've spoken about, I don't think anyone has a better understanding of emission chemistry in their process than we do. Right. Finally, the MTU is very useful for knowledge generation. We have, as I said, models and simulators to understand what are the implications of different process parameters, and these models are fed with real data from the MTU. So it's a self-propagating, perpetuating system. We also generate know-how, and that's difficult to quantify, but it's so important, right? Because now we understand what happens when you treat a flue gas and we have a furnace shut down. What's going to happen to the plants? We know what the operator has to do now, because they have to deal with this in real life. Right. And the final aspect that I want to talk about is the MTU used for innovation. Since the MTU exists, since 2008, a huge part of our portfolio, our technological portfolio, was qualified, validated in the mobile test unit. This includes the anti-mist configuration to reduce the emission of aerosol particulates, the energy saver that Monica was talking about before, and UMCM as well, ideas that didn't float very well or not concluded, like innovative stripper configurations. The reclaimer has been well tested and perfectioned with the N2, etc. And of course, all of our proprietary solvents have been developed in conjunction with their tests with real-life applications. I'm not a presenter, I'm an engineer, so I have to finish all of my presentations with conclusions, but I'm just going to repeat myself. The M2 is important for de-risking the application of large-scale carbon capture technologies. It de-risks the process. It follows the BAT, recommended by the British Environmental Agency. And you have a break. Thank you very much.
Thank you. Thanks a lot. Thank you. Thank you, Ricardo. Such exciting stuff to see the real-life data in action. Despite my deliberate scaremongering, we actually are on schedule. We now have one request just for everyone who is online. We all have the green room is open, so we can go through some Q&A. Keep please feeding the questions into the system. We now have quarter of an hour, so I can request, this is going to be a challenge, I know, but we're going to request everyone to be back at 2:15, when we can launch into the second part, which is a market overview, Carbfix, storage. You'll never be able to think about fizzy water in the same way again, and moving then on finishing off with blue hydrogen. And then we'll move to networking. But right now, you have about 14 minutes to grab some coffee and glucose, so see you back soon.
Do we get a countdown? Brilliant.
Right, welcome back, and what a fantastic event this has been so far. We've really seen some high quality presentations, and today we're here at the Green Room. We are delighted to have a close interview here with Valborg Lundegård, our CEO. Welcome.
Thank you very much.
Valborg, it's been you need to keep your microphone out there.
I will when I speak.
So heat recovery, a lot of focus on energy, but you mentioned cost. What is your perspective on this, and how is this driving our customers, and how they make their business case come together?
Well, first, the ultimate target for us is to drive the CCS industry. Make sure that it accelerates, that this is now the time to act. And we can always look at others, ask for funding, ask for taxes, incentives from governments and so on, but we have to take our part of the responsibility. And as a company, a carbon capture company, we have to reduce the cost to make these projects value for money for our customers. And technology, improvement, energy optimization, like we heard about this morning, is part of that. In parallel with other initiatives as well, like I said, modularization, standardization, working with suppliers and partners.
And Valborg, we're here on the 12th of January in 2023, setting the course for the next of the year. Could you share some light upon what's the big milestones for Aker Carbon Capture in the year to come in 2023?
Well, we have two main projects in construction phase right now. And of course, my first thing is to look at those. In Brevik, there will be a lot of very important equipment being delivered at site. We already have the major columns being delivered. I was there just on Tuesday. And of course, a lot of construction work will take place. But maybe, as I referred to in my introduction, Just Catch. We will have the first Just Catch in operation by the end of the year in the Netherlands at Twence's site, and I'm really looking forward to that. And then there are, of course, other milestones. We heard Ricardo talking about the MTU qualifying for the smelter and process industry. That's important. And of course, markets. We are looking at North America. and the IRA, and also Canada's ambitions. So let's see what happens.
Excellent. And while you were listening to Monica, of course, we wanted to get an in-depth interview with one of our super experts on heat integration and how do you actually capture heat. And I think we all were very much wiser when we came out of Monica's presentation. Monica is coming here over to the green room. Monica, thanks for being with us.
Thank you.
So, heat integration, you explained the basics, you explained how it all works, but tell me, how did you yourself get interested into this? Because this is something that you're really passionate about.
Right, that's a good question. I remember actually my first subject in thermodynamics, I learned this principle about energy always being conserved, and I was really kind of fascinated by the ways in which we can make use of that principle to basically just use less energy. That is really fascinating that the laws of nature are kind of on our side and we can exploit them to make the technology that we want to make, basically.
And you talked here specifically about the technology. You mentioned in the cement industry. Talking about the heat optimization and energy efficiency in specifics, is there other industries which are typically relevant to mention in that respect?
Definitely. Several others, which all have their own kind of energy challenges. You have metal industry, which is a good industry in many respects because typically there's a lot of waste heat so that we can use very little energy to run the capture plant. But there's also this other industry that's maybe a bit more kind of complex and there are more opportunities, which is the waste energy industry, right? Where our waste is burnt and used for power and district heating generation. So I think that's a really interesting industry because there are many ways that we can integrate our capture process with this type of industry by, for example, supplying district heat from our carbon capture plants to the customers of the waste energy companies. So that's an exciting industry for us to work with many opportunities for energy optimization.
And I'm sure there will be lots of people in the break and after, also during the mingling time to want to ask you a question. But I can see there were a couple of questions coming in now online, and one of them was really direct. Have we seen everything there is to innovate when it comes to heat integration, or do you think there will be advances also in this type of?
Well, that's a good question. Yeah. Hopefully not. I don't think so. I think we can still work on getting that energy use even lower, just to make carbon capture as easy as it can be, right? Which is what we all want, I think.
Absolutely. And one more maybe. You talked about energy saver and how we are making some of this knowledge and some of the technologies that we bring together into new products. Can you tell us a little bit more about that? Will we see new models of this being developed?
Right, yeah, that's an interesting thing, that we're not just developing technology, sitting with our pens and kind of writing papers. We're actually making products that we can implement directly into our different projects with the customers. So yeah, that's a good way of not only we're not only reducing energy, but we're making cost-efficient, standardized products. In that way, we can also try to drive down the costs of these different heat integration solutions.
Absolutely.
And Valborg also mentioned here at the end the markets and how we see that going forward. And just now after the break, we'll have a presentation actually by me on the markets. Yes. You talked about waste of energy, you talked about cement. Any specific markets that you think is interesting in that respect, geo-markets as such?
Geo-markets, yeah. I think that within waste energy, for example, that I mentioned, I think that Scandinavia, Sweden, Denmark and Norway, for example, are really interesting markets. They have a lot of waste heat and they have a lot of waste to energy, right? They also supply a lot of district heat. I think that that's a sector where there's very interesting potential to deliver carbon capture plants with very good energy values with as low as possible energy penalty.
Very exciting to use the operational experience from Twins then in that future industry in those geo-markets, I believe.
Absolutely.
Right.
Monica, thanks for being with us, and thank you everyone for online for asking questions. Do continue to ask questions. We're going to leave Monica now, and Emil as well, because he's going to head out to do the presentations in a minute. When we come back, we're going to talk about what is the market for carbon capture, how is that developing. We're going to talk about some really cool transport and storage. We have our partners here, Carbfix. They're here to talk about where they are with their fantastic projects, where their new Coda terminal, which received EU Innovation Fund funding. So don't go away. Use the break to a quick bio break. We'll be back in a couple of minutes for more live here from London.
Gents, hello. Hello, hello. Okay, we're on. Good, thank you. Okay, this is your 2-minute curtain call. So if you wouldn't mind taking your seats, glad you managed to fit in coffee and glucose so efficiently. And we'll kick things off in the next 1 or 2 minutes. Thank you. Everyone, welcome back. Thank you for having such an efficient coffee break. I thought this time I would avoid talking over the intro, although I quite enjoyed it. Maybe that saved us about 10 seconds in the first half. Second half, 3 talks to go before you can enjoy the networking. Just to remind everyone online as well, we continue to have an active Q&A function, so please get involved in that. And for those of you who are not here to enjoy the after presentation party, there is an online after presentation party with a number of our colleagues, so please do stay online to see what other content we'll be sharing them. So second half, a very exciting 3 sessions to go. Market outlook, then we have Carbfix, and then we have blue hydrogen, and then we'll jump next door for networking. So great pleasure to introduce my colleague Emil Yde Arsen from Oslo. Over to you for the market outlook.
Thank you, David. Yeah, indeed. Building what Jim Stian said before the break, we're trying to learn you something here today, and I certainly hope you learned something before the break. I'm also going to try to learn you something, at least give you a bit of an update. What will drive the CCUS market in 2023 and potentially also beyond that? So starting with that, I'm going to show you 2 curves here, and for those working in CCUS, I think these are familiar to many of you. What you see to the left side here is the graph showing from the Global CCS Institute how the CCUS capacity has grown throughout the years. Great development in terms of future CCUS capacity to be deployed, but what I want you to take away is not the green numbers on top on the 45% increase, it's actually the different colors to see here in the bar chart. So today we have about 43 million tons of operational CCUS capacity globally. What's happened over the last 2-3 years is that we've seen an almost exponential increase in number of projects being announced. So that's the light blue and darker blue colors that you see here. These are typically projects that will be or will need to be deployed over the coming years up to 2030, typically the projects that you see in here. So within the 196 projects, which are then representing the light blue and darker blue colors here, these are typically projects which hasn't taken FID but need to take FID in the coming years in order to be deployed and reach that cumulative capacity of 242 million total. If we then compare it to what you see here on the right side, That's actually today's operational capacity compared to the IEA's, the latest numbers from the IEA's net zero by 2050 numbers, which says that in order to meet a net zero by 2050 scenario, we need 1,200 million of operational capacity by 2030. Comparing that to 43, it's certainly a way to go, but if we compare it to 242, it looks a bit better, but still quite a way to go. That says something about the potential needed. But even more important is making sure that those light blue and dark blue colors become red by 2030. How do we deploy CCUS over the next 7 years up to 2030? This should be also a familiar curve for everyone working within CCS. This is talking about basically how do you make CCS work commercially, driving down the cost and also increasing the cost of emitting CO2 or giving a equal tax incentive to actually deploy it. One of the challenges with CO2 in terms of deploying it, or maybe the main challenge, has been that typically the cost of deploying it has been greater than the cost of actually emitting CO2. What I'm about to show you here now is I think this is about to change, and 2023 is a key year in that respect, much because of some changes that we saw in the second half of 2022. When we talk about these financial instruments that will incentivize deployment of CCUS going forward, it's all about the stick and the carrot approach. And starting with one of the key market for Aker carbon capture as of today, it's Europe, where you actually combine these two, potentially with a bigger stick than a carrot, in order to deploy CCUS throughout the market. So what you see at the top is the stick, the EU ETS, the carbon tax that is deployed, and you see the development throughout 2022 on that one. And below that, you see some typical carrots in the market. It's the Innovation Fund, it's the Connecting Europe Facility, CEF program, and it's the Horizon Europe, which all are set up to support development of CCUS at different maturity levels throughout various countries in the EU. However, also looking into the market, there's traditionally been one challenge with this, especially on the stick approach, and that's the fact that there is no flooring mechanism on the EU ETS, and that talks about bankability. How can you actually make sure that your project is bankable based on the EU ETS? Some of the weaknesses around that have shown lately in 2022 when you see the market response to some of the historical events that we've seen, and then the resulting decrease in the EU ETS. Actually, at the EU Parliament, it was discussed to have a flooring level at 60 euros per tonne at a certain point. This was pushed back by the Commission, but there are already discussions on this, acknowledging that this is a problem, but to date we don't have a flooring mechanism in the EU ETS. However, just before Christmas, as many of you, I guess, were finishing the inboxes and getting ready for the big celebration, there were big things happening in the EU. And here you see a bit of those summaries, because on the 18th of December, there was a big update as such in the EU. Basically, EU legislators reached a provisional agreement on the remaining EU ETS bills under the Fit for 55 policy package. I basically outlined some of the detail here, also for all of you taking pictures, which is great. You can read that further in detail afterwards. But basically, it says more ambitious reduction goals. So we've increased the EU ETS emissions to 62%. So that's the EU ETS emissions. Link that with point number 3 here, new sectors brought into the EU ETS, both waste to energy and shipping will be brought into the waste to energy. That increases the number of allowances needed, even greater pressure on the system as such. Even faster reduction of the cap, so it's a cap and trade mechanism, and the linear reduction factor has now been doubled to 4.4%, which also then sets the pace of this going forward. And lastly, but even more importantly even, is the free allowances to be replaced by the carbon border adjustment mechanism. We could talk for at least 40 minutes on each of these, but the result of them, if you look at them, is actually summarized very well by Bloomberg New Energy Finance, who said they previously, prior to this, had an average EU ETS price of 79 euros per tonne, but they upgraded this by 10 euros for 2023 to 89 euros per tonne because of these changes. Remember that number, 89 euros per tonne. Secondly, there was also further increases or enhancements in the carrots as such. So the EU Innovation Fund, the main instrument for deployment in the EU, which to date has almost used 50% of its budget to support CCUS projects, also get an increased budget as a consequence of the Fit for 55 package. The third call for large-scale projects was launched last year, and we will see the results this year. 3 billion total budget, almost double the budget in that call. So looking forward to see those results coming later this year. And also the modernization fund, which will typically favor those countries who are in parts of Eastern Europe in terms of deploying decarbonization solutions going forward. So even though there's no flooring mechanism in the EU ETS, this will make a big change going forward into which industries will actually now start to be able to actually look at the bankability of CCS. Looking at another market which had very favorable developments in 2022, and especially going forward, is the US. They don't use much of a carrot and stick, they only use the carrot, and they use a whole bag of carrots as such. The biggest carrot of them all is the Inflation Reduction Act and the enhanced 45Q. So for those of you maybe familiar or not familiar with 45Q, basically what happened under this one is previously for CO2 captured and permanently stored, you get $50 per ton support. That was prior to the Inflation Reduction Act. After the Inflation Reduction Act, that was increased to $85 per ton. That's a flat basis. You get that support either as a tax credit or a direct pay mechanism for the first 7 years. You can choose between the two. In addition to that, there's additional carrots in the Bipartisan Infrastructure Investment and Jobs Act, which then gives dedicated support for development of bigger CCUS cluster infrastructure, combined also with hydrogen hub developments across the US. So right now there's a big competition going on exactly to win that support. And as if that wasn't enough, you actually have state-specific support as well, such as the Californian Low Carbon Fuel Standard, which typically then, if you go into the details of it, is specifically a driver for direct air capture and also likely biogenic emissions with CO2 going forward, so-called CDR, carbon dioxide removal credits, will be a very interesting market going forward. There are some laggards we need to notice here. It's the access to storage in the US. Typically, Class 6 wells used for CCS have a permitting time of average of 3 years, but there are light spots in that, definitely in North Dakota and Wyoming, for example. Both those states have primacy over sequestration rights but within the state, which typically lowers that time to actually permit the storage. And also Louisiana and Texas are looking to get the same. But all in all, and please bear in mind that this IRA passed after the Global CCS Institute showed or published those numbers that I showed you previously. So even with the announced project on 242 million in the pipeline, that was prior to this, which is going to further increase it going forward. But most importantly, this drives deployment. What you see here is a curve from the Princeton University, and they looked at what was the deployment rate of CCUS prior to the IRA and after the IRA. Basically, they saw a 13 times increase in deployment, which says something about the impact of this going forward. Other events I want you to keep in mind and why 2023 is going to be such an important year is basically highlighted here. In Sweden, we'll have the launch of the reverse auction for bio-CCS, likely in Q4 2023. They're asking for feedback from the Commission right now in terms of the state auction, reverse auction that they set up. And they expect about half a year, 6 months to get that feedback. And then it will be launched in the second half of 2023. In Denmark, we'll likely see now the award of the first round of Danish CCS funding of minimum 400,000 tons already now next month. So that's going to be exciting for sure. Here in the UK, many people are asking themselves, what is the timing of the phase one or the track 1 phase 2 projects? Well, first of all, we're going to get a further shortlisting. 20 projects were shortlisted across the UK, 14 in the East Coast cluster, and 6 in HyNet. That's being cut down to we don't know how many yet, but that's going to be key. Launch of track 2, and also potential funding announcement for track 1, hopefully by the end of this year, potentially sliding into next year. That's going to be key. Netherlands funding award size of a record budget for SDE++, which is the national budget or national funding mechanism for decarbonisation in Netherlands. The results from that coming now in the first half of this year, and also the launch of the next round with a slightly lower budget, but still very interesting. And lastly, but surely not to be forgotten, is the launch of the German CO2 management strategy. Big industrial engine of Europe are now looking at CCS, CO2 management, in a different light. That's going to have a big impact on how the CCS industry in Europe specifically will develop going forward. So all that, in conclusion, I think we're here today. I think we're at the breaking point where this now starts to make sense. It's very much regional dependent. Why do you see this drive in the US? Well, it's basically because you have a flooring mechanism of $85 per ton, and transport and storage are typically more cheap than what you would see here in Europe for now. But again, EU ETS is set to increase going forward. It's a very sustainable mechanism to drive deployment on the midterm as such, and 2023 might be the year that we look back to and see that's when it happened. Thank you, everyone.
Thank you, Emil. Yes, it's challenging to cover any one of those topics in quarter now, let alone the whole market outlook. So that's a really good run through. And I can tell you one of the most intense discussions we have with shareholders is this whole discussion between carrot and stick and a bag of carrots. Maybe I'll start using the phrase bag of carrots a bit more often, actually. But anyway, so the next up is a fascinating topic, storing CO2 in Iceland. We're delighted to have one of our key industrial partners, Kristin from Carbfix. So Kristin, over to you.
Hello, everyone. My name is Kristin Gilarsson. I'm heading business development for Carbfix. And thank you for inviting me, Valberg, Jim, and JC. So not sure if everyone knows what Carbfix is, but Carbfix is literally a 3-year-old startup with about 17 years of R&D history. So what we do, and I'm going to educate you today and tell you a little bit about this. We have been turning CO2 into rocks or stones since 2012, actually on an industrial scale. So the idea is that a dialogue between 3 universities happened in 2006, where people started thinking, can we replicate Mother Nature's way of storing CO2 into the bedrock? It happens to be that Iceland is a predominantly volcanic island, a lot of basaltic rock. So the basaltic rock is actually a very good rock for storing or mineralizing CO2 into. And we are known for quite a long time that Mother Nature's way of storing CO2 into the, where it keeps it is actually below our feet. About 99% of all stored CO2 is actually below our feet. So the task was to replicate or imitate, which was actually very successful. So these 3 universities was University of Iceland, Columbia University in New York, and CNRS out of Toulouse in France. So the end result is in this beautiful rock here. This is basalt, and the white dots, this is actually CO2 that's been mineralized into the bedrock itself. This process actually takes less than 2 years to materialize. And just to put it in more perspective, I think Jim Stian showed you some slides earlier. The velocity of the problem that we're facing. This is Iceland's most prestigious waterfall called Gullfoss. Imagine you'd be standing there for the next 40 years, every second, every minute, hour, day, week, month. That's the equivalent amount of CO2 that we need to avoid. So we're talking some serious numbers here. These are figures from the International Energy Agency. Just to put it into perspective, the CCUS, the U is missing, all this, we have a lot of technologies out there. We need them all, whether it's utilization or storing or mineralization, whatever we call it. But these numbers are quite significant. We're talking 1,000 billion tons that need to be avoided in one way or another. So how do we do these things? So in the simplest form, was mentioned earlier, you would probably look at sparkling water in a different way after this presentation. But in short, we take Perrier and we pour it into the ground. So pretty much we mix water, we dissolve the CO2 in the water. And this we do with, let's say, quite significant amounts of water. But usually the rule of thumb is 1 portion of CO2 and 25 of water. So what we do here, we dissolve the CO2. So we inject it gently into the basaltic rock. So the magic or the difference between this type of mineralization storage and the traditional enhanced oil recovery, or using old oil and gas wells, is that we are building networks of wells, and I'll show you a little bit later. So the depth of the well is very shallow, only about between 300 and 800 meters. So that's quite totally different than what we're used to. So once the highly acidic liquid, water, dissolved CO2, enters the bedrock itself, the mineralization process starts to take place. So pretty much we are simply using the water as the means of carrier for the CO2. You can think of it as the train and the passengers. So the train reaches the basaltic rock, the passengers jump off the train. That's what happens in reality. And we have published over 100 papers to prove the case. And this is not something that we come out with now. This is based upon pure science since 2006. So the calcium, the magnesium, and the iron, they get released, and the mineralization process takes place. And this actually has been proven, as I said. This happens in less than 2 years, and actually it happens in the first 6 months of the process. So the end result is that you see in the basaltic rock, it is very porous, and the water just carries on its own way, but the CO2 is left in the bedrock itself, as you saw on the first page. This is before, and this is after. You see the porousness of the rock. It's quite extraordinary. And I'll show you some pictures later on. The capacity, the storage, estimated theoretical storage capacity in Iceland alone is quite significant, but on a global basis, it's even more, of course. So just a quick story from where we come from. We are actually owned by a public utility company, which is ultimately owned by the city of Reykjavik. So we are, in that sense, a public entity. But we are now just changing gears and moving forward with the idea of commercializing the idea. We are, let's say, we are operational in 2 commercial projects and building many more. And I'll go into that a little bit later. But scaling up and commercializing is what we need. And we don't have much time, and I think the previous presentations showed you that we have to act as quick as possible. So this is a schematic of our original pilot project at Hellisheiði in Iceland. We are actually, as I said, come from a spun from a utility company, which operates a geothermal facility. There we actually did the entire value chain, the capturing, the transport, and the actual mineralization. And at this particular site, the total cost of value chain is less than $25 per ton, which is unheard of. We are not going to be focusing on the actual capturing. Our expertise lies in actual mineralization. And that's why we are partnering up with the likes of Aker. And we are actually currently, let's say, exploring quite a few projects in Iceland and in Europe, and hopefully in many other places going forward. One of the big things in this is how can you commercialize it? How can you verify? How can you quantify? And how can you get money out of it? What we have done, we are the first and the only, with our collaborative partner Climeworks, to have our actual technology verified and certified by DNV. So now we can actually, well, we can verify carbon credits and issue them based upon the volume and the amounts that we inject into the ground. So this is something that is, of course, needed, both on the mandatory market as well as the voluntary market. Just some pictures from our operations in Iceland. And actually, we are operating with our friends at Climeworks, the world's first direct air capture facility, which is called Orca. And they're actually building the second one right now called Mammoth. On the far bottom right, you have the DAC facility. On the top right, you have our scrubbing tower where we dissolve the CO2. And in the top left corner, you have the actual igloos where we inject the CO2 gently into the ground, where the end result becomes a rock with CO2 embedded in it. I mentioned earlier the storage capacity. Iceland, theoretical storage capacity, 2,500 billion tons. That's quite a significant number. And people would think, okay, so you're going to do this in Iceland. Yes, we're going to do it in Iceland, but we're not going to be limited to that particular place. We actually were so lucky that we actually are the receivers of European Innovation Fund that Emil mentioned earlier. So we have a project called Coda Terminal. I'll give you a briefing on later. That will be the world's largest mineral storage site. It will start operation in 26, and in 2030-31 it will have a full capacity of about 3 million tons per year for 30 years. So just in that one project, we're talking about 90 million tons stored, mineralized into the bedrock. Excuse me. Iceland has the capacity to do more projects, and in the near future, we of course will do so. But the idea with the scale-up and the commercialization is to make this globalized. And to do that, if you look at this map, this is actually accessible on a website. You can go in there and have a look where the feasible sites on a global basis are. About 5% of all land on Earth is covered in basalt. About 70% of the ocean floor is covered in basalt. So the potential there is enormous. In regards to the technology right now, we are using fresh water. We are exploring usage of salt water. So you can imagine the possibilities once we have that, let's say, solved. We already have done all experiments in lab. We're just starting a research project in Iceland on seawater as well. So that's like opening Pandora's box in a very, very positive way, because the possibilities are almost endless. In regards to the focus, where we want to focus on 3 regions in the beginning: Europe, North America, and certain parts of Asia. And I think Emil explained pretty well why that is. You have the sticks and carrots, different combinations of these matters. So all in all, our mission is to be a key instrument in tackling the climate crisis. And then you ask, how are you going to do that? So we're going to be focusing on 3 paths. The first one, the on-site capture. Think of it, if there's an emitter, Aker can capture it, we will receive it and injecting at the site. That will always be the most feasible economically wise, if the geological conditions are favorable. The second one is using direct air capture. As I said before, we are the only company operating commercially in the DAC facility. We are the receivers of 2X prizes, which is the highest achievement in that category. So we are the party that people within the DAC industry will come to. And the last but not least is the transport to mineral storage hub, which is like the quota terminal that I mentioned before. So the quota, the idea behind that is to pick up from emitters in Europe and the UK to ship to Iceland. And it will be shipped through specialized vessels. At the end, there will be 5 vessels, each about 22,000 cubic meters. So we're talking about some serious size of vessels. So this project, this is the site that it will be. This is Rio Tinto aluminium smelter facility just on the outskirts of Reykjavik. So this has been expanded a little bit, so the harbor is not there yet. That is the on the left side. But the infrastructure will be available for us. And we are actually starting to drill our test wells, actually right here. Just to give you an idea, I mentioned before the wells, the capacity. So each well can actually, we are anticipating about 30,000 tons per well. So each well pad can have up to about 8 wells in it. So it does not take a lot of space, but the capacity that we can actually mineralize or store there, just at this site, is about 800 million tons of CO2. We're only going to be using 90 million. So what we want to do parallel to everything is replicate this across the globe and work with partners. We will grow, we will be big, but we will not be big by ourselves. We need strategic partners. And I think that's been kind of the element through this session here, that partnership is the ingredient, whether it's utilization, whether it's capturing, whether it's transport or mineralization. This is just our timeline in regards to that particular project. We have been extremely lucky to have received quite a lot of media attention across the globe. And you know, we will be getting more and more, I can tell you. We are so appreciative of it that, and the reason for that is because this technology, it is kind of summarized here. It's a nature-based solution. This is what Mother Nature has done for millions of years. We are simply replicating and speeding the process up. It's a very low-cost technology. We have estimated around 400 million euros the cost of the entire Coda project, where we are comparing it to other projects that cost 5, 6, 7 times more than that. And the operating cost is much lower, much lower. So from a cost, it's highly economical. It's a safe. I've never seen a stone change back from being a stone into something else, unless there's a volcano. So there is no risk of leakage. It's a permanent solution. The capacity is almost unlimited. I mentioned before Iceland. Just North America is about 3 times the capacity in Iceland. So we're talking 7,500 billion tons. That's huge. Last but not least, it's based upon science, and science doesn't lie. This is where we are. So we are not just an idea. We are actually operating 2 facilities commercially. We're building 2 extra ones and more to come. These are the places that we're actually doing projects on: Asia, Europe, North America. By the end of next year, we will have every continent except Antarctica. The technology is not limited to Iceland, and the capacity that we can is quite significant. So where we are right now, we want to focus on getting as quick as we can towards the 1 gigaton. We are doing that by the 3 paths that I explained to you. We are doing a lot of consultancy work, working with the biggest companies in the world. Let's say a company has facilities in 50 countries. They want us to check if the geological conditions are favorable. That's what we do. So the first foundation is the consulting, because we don't start a project unless we know exactly that the geological conditions are favorable. We will license out the technology. We do have IP, and we also have patent pending solutions. We are developing offshore, I mentioned, regarding the seawater. And last but not least, we are also exploring other rock formations than only basalt. That's Carbfix. Thank you.
Thank you, Kristin. Absolutely fascinating stuff. And I think you're setting a really high bar for visibility as well. I mean, we have yet to appear on Netflix, but maybe give it some time. But you comment about the academic literature, by the way. Do have a look. There's an enormous amount of information you can look at that really shows very, very solid science behind this, using radioactive carbon to track how much is being stored. And as you said, the standard pushback sometimes is, oh, this takes ages. Like, no. Over half of it is done within a few weeks, let alone 6 months. So do have a look. There's a very, very good session of weekend reading for everyone. So we are now on to our last presentation before we go to the informal part of today's proceedings. This is all about blue hydrogen, a real success story from our testing angle. I'm delighted to introduce my colleague Ryan. Over to you. Have one of these.
Thank you, David. Does this work? Yes, excellent. Thank you, David. So it's a little humbling to be the last speaker today after the excellent list of talk we had. And it's also, I can see the pressure from the crowd, and I'm between you and the drinks. So I'll try to be as concise as I can. So as David introduced, I'll talk about a success story that explains why blue hydrogen is within our key markets. So when I was asked to put together the slides, and I decided I was going to do a good job, obviously, and put up a few slides that took me about 45 minutes of presentation. I was like, yeah, I've got some time left for the questions. And then some weeks ago, I was like, so Ryan, you ready for your 15 minutes presentation? I started sweating heavy, and I was really wondering, okay, how the heck am I going to start hacking into this? But it turns out that my colleagues apparently really love me. So they started talking about energy in CCS, they started talking about mobile test unit, and they talked about how to save energy. So I only can focus on the sweet stuff. So, well, jokes aside, this case study today is going to be presenting the PRIM CCS project, which is carbon capture on a hydrogen production unit at a refinery in Sweden. The PRIM CCS project was an exercise, a project that was financed bilaterally by 2 nations, nation of Norway and Sweden, to demonstrate that CCS, a full value chain, capture in Sweden, and transport and storage in Norway, was realizable. There was a whole list of different stakeholders. It was a multi-million pound project over 3 years. Aker was the technology provider. And so we had quite a large, let's say, umbrella responsibilities, and which fell in two work packages. The first one demonstrates that our technology actually works on a hydrogen production unit. That's with the MTU. So you can see where I'm going with this. Use these results and establish a feasibility study with all that comes within the scope of a feasibility study. Of course, the design, the layout, and the cost. So I will talk about all of that today. So I hope you're ready for some good stuff. Before I do that, I just wanted to take a moment and pause and talk about the team on site. Mobile test unit team, without whom we don't get the results that we get. We don't get the experience, the know-how that Ricardo talked about. But also the host team, without whom we can't get the quality of the result, without whom we can't understand the specifics of the site, the fluctuation, the needs. And the value of the results we get is only proportional to the nature of the collaboration with the two teams. And you can see from the smile on the face of the people in the picture, which are the two teams, the MTU team and the Premium team, that actually was quite a good campaign. And that explains certainly a lot. So thank you for them. So I won't delve into the nitty-gritty of the campaign. I think this is not the right platform for it, but I will, however, talk about some key takeaway. The campaigns, actually, it were two campaigns. Monica talked about the open solvent, monoethanol amine, which is the reference benchmark solvent that usually is used in most studies. We fed this solvent into our mobile test unit for several hundred hours. What we noticed is that the MEA started degrading heavily, visibly, and we started having emissions that were haywire. And so we drew our conclusions and decided that it was time to move to another solvent instead of just emitting to the birds. So we used one of our proprietary solvent. And we didn't operate just for 100 hours. We operated for over thousands of hours, so over 3,000 hours. And you can actually see the state of the solvent, absolutely pristine. It didn't change visibly. The performance were stable, energy performance-wise. The emissions were minimal, orders of magnitudes lower than monoethanol amine, and the degradation rate was also an order of magnitude lower than monoethanol amine. Better energy performances by a margin. Also, this graph shows that capture rate is not limited to 90% with our technology. And so we went through a little exercise. We had some more funding. And we went through a little exercise and see, can we push to higher than 90%? And there was no discussion on ultra-high capture rate back then. It was during the COVID years. So we just did that for the sake of science, let's say. And you can see that 95 over, it's not a technological challenge for us. So just, I'll close that bracket. So the MTU campaign brought us some conclusions, and that was also the objectives of the partnership. Demonstrate that the risk associated with operating our technology at the customer site is minimal, is low. And that's what we did. We operated on real flue gas for thousands of hours and demonstrated the emissions were at the minimum point. We had low degradation and we had predictable performances, which is what you need when you have a new technology that is introduced into your operation. So this led us to think with a great amount of confidence that ACC's technology is absolutely well suited for blue hydrogen. Well, now the question is, okay, how much it costs? So I'll come to that. But we were talking about scientific publications, and we have generated a lot of results, and we've worked, historically we always wanted to push publication, work with the scientific community, so we've published a lot of our work, and it's all available, and we're happy to share those links. Fun fact, coming back from holidays, one of these papers received some emails that it's daily on the top 10 of the most download from the paper that's published. That's the journal that's published the paper. So, it's getting some traction. And with the recent announcement around Germany and Norway, we really kind of understand who is downloading this paper. So the full-scale feasibility study at PREEM, the scope was to design, provide layout, and obviously a cost, which for the feasibility study is around plus minus 40% accuracy. And the size was 90% of the capture. 90% of the capture. Okay, I'm going to move here because it's good to be dynamic. 90% of the capture that's actually produced at the PREEM facility. So 600,000 ton. How big is it? We've talked about Breivik, the first retrofitted cement plant in the world with carbon capture. That's 400,000 ton. So this is 1.5 times as big. Give you an order of magnitude. The flow rates involved, I'll give you some metrics there. It's always nice for a conference with industrials to have some metrics so you can compare with. Quite high volume, around 200,000 normal cubic meter per hour, and a concentration of CO2 around 20%. So what's behind these metrics? I'm just going to touch upon the process of generating hydrogen. Don't worry, I won't go into too much detail. Basically, generating hydrogen from natural gas is a three-step process. And what we need to understand is that there is a lot of inputs and outputs. There's also a lot of CO2 that's generated. So that is not a problem per se when you have a carbon capture technology. The problem is the CO2 is split between each of these streams. So if you capture CO2 on stream number 1, you only capture 60%, 50%. If you capture CO2 on stream number 2 or 3, you capture the rest. So if you want to really talk about blue hydrogen, you have to capture CO2 on all these streams, and economically speaking, it's hard to justify. So another configuration is to actually use a recycle loop and capture the CO2 from the only outlet, and that allows you to play with the totality of the CO2 that's generated. That is a configuration we have investigated for the PREEM feasibility study. So just a little bit of an introduction behind blue hydrogen. Okay, but I'll close that bracket and talk about energy because that's the theme of the conference. So, how much really energy did we need for the PREEM feasibility study to capture 600,000 tons of CO2 per year? My boss, Jim Stian, really makes amazing slides, so I just copied that from him. So thanks, you. What it shows is that our solvent, as Monica said, needs heat, but in the end it doesn't really care where the heat comes from. So we've put together with our colleagues internal heat integration from the process we operate. That means that we reduce the demand on the customers, from the customer's eyes on heat we require. But it's still a little bit of heat, and that heat means cost. So within our scope in the feasibility study at PREEM, it was important for us to evaluate and assess how much heat could we extract from their operation and their site. And how much heat? Actually, all the heat we need. We went through an extensive heat integration and waste heat upgrade. It wasn't readily available. Of course, it requires a little bit of investment to lift that low-grade temperature. But in the end, to the eyes of the customer, this process was just an electrical process. So I think this is where it gets interesting. And we were talking earlier about if you have energy optimization, you should do that first. And that's what we did here, which means that in the end, the solution we offer to the customer meant that they only had to put on the table 0.8 gigajoule electric per ton of CO2. So that, if you remember Monica's scale, it's on the lowest range. It's actually one of the best number you can find on the market. So an extremely interesting proposition for the customer. Yep. And just to prove that this project can be realized, we just need about when. I've laid out here the different main process units with the carbon capture on the bottom left, compression included. The CO2 liquid will be transported to the CO2 storage tank halfway between the capture unit and the harbor. And that also was another positive point from the Prim Lichterkeel refinery. They have a harbor, so that was ideal configuration. So it's real. So this leads me to my last slide. How am I doing on time? About that, that's good. This project was dual, and it led us to a strong conclusion, which is that ACC's technology is de-risked on hydrogen generation process. It's not only de-risked on a technological perspective, on an environmental perspective as well. We've operated on real flue gas for over 3,000 hours with our mobile test unit, a process that is proprietary to us. And we also have provided a very interesting, cost-efficient business proposal to our partner. And that is very likely to be repeatable across this industry. So this leads us to think with great confidence that blue hydrogen is the right market for our technology, and vice versa. So maybe I'll stop here and just ask you to, next time you hear about blue hydrogen, think about us. Thank you.
I'll take it. Okay, everyone, thank you so much. This is the end of the formal part of our session today. It's really appreciate your interest. I think from my mind, I mean, it's been great fun to be part of this, of course. But I think from my mind, three things really stick in my mind. Number one is partnership. Clearly, this is a young industry, and for us to make the most, and we can accelerate by collaborating and by working together. That's very clear. And it's delighted to have Man Energy and Carbfix to join us today. That was fantastic. Thank you so much. Secondly, energy optimization by using engineering experience, understanding heat flows, understanding data science, Minecraft. Again, I'm surprised it was mentioned, but it's a great one. But again, that picture is clearly, if you want to pick a theme through our slides, it's been optimizing the energy consumption. So we have an ambition not only to be a very leading supplier of the plants themselves, but also the operation of the plants. And this will be an absolutely core part of our skill. And thirdly, I have to say storage, Carbfix. It's a fascinating story. And again, a reminder, weekend reading, just look at some of the science about mineralizing storage of CO2. So that is it. I think the last thing I would say is from behalf of everyone at Aker Carbon Capture, thank you so much for your interest in person and the many hundreds we have online. We now have the informal part next door, if you're here in person. If you're online, I'm afraid you have to stay in front of your screens, but it's almost as exciting to join some of my colleagues to have the after-party online version. But thank you everyone again, and see you next door. I can lose this finally.
Hello everyone, and welcome back to Aker Carbon Capture Technology Day. And we're live still here from the venue here in Westminster Bridge, where people are now going out to find each other and do some proper networking. We wanted to provide you with some real in-depth interviews here with some of these excellent speakers that you've seen today. And while we are waiting for them to come to our green room, I have you here, one of the speakers, Emil. Thanks for this inspiring talk about the market. What is it that you really, people should be left with? Because it was a bit of an optimistic tone that you had today.
Working with CCS, you have to be optimistic, and I think 2023 is the year that many things will come into FID. It's certainly a key year for CCUS. There's also many markets that we didn't get to talk about. We didn't talk about Canada, we didn't talk about the APAC regions. There's so much going on in CCUS these days that it's easy to be optimistic, actually.
And we're seeing, costs coming down very rapidly. And I can see now that one of our key partners is coming into the picture, and I have with me now Kristen. Thanks for taking the time to join this after party here live on our YouTube stream. And Kristen, you've been with Carbfix for some time now. What is it that people are most amazed of?
Sorry. So I think educating people about the new technology. It's ultimately not a new technology. It's simply, demonstrating what Mother Nature has done for the last millions of years. So we're now, educating people about the possibilities that this technology has.
Absolutely, and I know that you guys have been working now to take the next step in terms of using not only freshwater, because you talked about some of the volumes that are necessary in order to do so, and now into saltwater. How is that coming? Because I guess that will be a very, very important step for you guys.
Yes, absolutely. So we are actually right now doing a test drilling in Iceland, where it's a project called Seastone, very original, and where we are drilling close to Keflavik in Iceland, a well that we can actually inject imported CO2, because it's a collaboration project with Swiss authorities in ETH University in Zurich, where we will receive the CO2 and then we will inject it into the bedrock, and hopefully we will have some preliminary results within the latter part of the year.
And how much, just to jump in front of you, Emil, how much does that really, how much more market does that really open up?
Well, as I mentioned here earlier, about 5% of all land is covered in basalt, but about 70% of the ocean floor. So you can imagine where water is scarcity, like let's say the west coast of the US, like the west coast of India, just to mention some, where water is difficult, is a valuable resource. Then if we can utilize seawater instead of using freshwater to get rid of the emission, then I think that is, you can't put a price on it.
Fantastic. And talking about price, that's what I want to squeeze in. I talked a bit about how transport and storage price drives the business case for CCUS across various regions. You showed here below $25 per ton. How do you see yourselves in terms of the cost driving CCUS deployment across the various regions that you talked about?
Well, we will drive it with partnership, collaboration, strategic partners like yourselves. But most importantly, again, coming to educating people about the possibilities that you can actually inject, dissolved CO2 on land. There's no risk associated with it. So we have to, let's say, Rome was not built in one night. It's a patience game. We have to work with policymakers and try to make things move forward, and with our partners like yourself, as I said.
Really interesting.
Absolutely. And I think one of the key themes today, of course, has been cost reduction, and we'll be coming into more on cost reduction as we go across these interviews later today, and also going forward when we are broadcasting live on our LinkedIn account. Kristen, it's been fascinating to have you here. What is the next? We talk about our next generation products. What is the next generation Carbfix?
Carbfix 2.0.
Yeah.
Carbfix 2.0 probably will be using seawater instead of using freshwater. Carbfix 3.0 will probably by using other forms of rocks than simply using basaltic rock. But first and foremost, we're focused on the current project that we're operating on. The Coda Terminal is a project of demonstrating the scalability of the technology. That is hugely important. But parallel, we want to launch this on a global basis. So that's our number one focus right now.
Absolutely. So a lot of things to look forward to, and I'm sure there are listeners online that will notice that Coda Terminal, of course, coming up as a solution to transport and storage for volumes in Northern Europe. So excellent. Kristen, thanks for having us. Thank you for having us with us here, live here in London. I can see that we have Simen as well, so I'm going to steal your Microsoft and then see you later. We'll have Simen come in because I can see there are already a lot of questions. Simen, of course, one of our most popular speakers here today. I can see from the good questions that you have been posting online, and now you're here. Simen, how is it like to be a data scientist in Aker Carbon Capture?
It's very exciting because now we have had data science in operations of different facilities over the years, and it's so exciting to see that you can use some of the same tools and apply them to data science or apply them to carbon capture instead. So right now I presented some of the generic tools, for example, for pumps that fail, and people have seen that before, but applying them to carbon capture and then see what the next levels could be to make the process itself even better, very exciting.
And what's your advice? Seeing your enthusiasm for CCUS and data science in front of here really inspires me, and what would you say to other data scientists out there looking to get into CCUS?
Give it a try. I have a few friends that are also data scientists, and they work in the bank industry and things that, I really want to apply data science as something more meaningful. And there's so much potential out there. Look at where the world is going in terms of carbon capture, and then use the same principles as you have elsewhere and apply it to carbon capture instead. I think there's lots of opportunity out there, both in ACC and also elsewhere.
I think our career email is going to be overflowing.
Absolutely, and everybody online, of course, now knows from Simen's comments that actually having some Minecraft experience is going to be key going forward. So looking at your longer roadmap, when do you think some of these things that you see in the longer perspective, when do you start testing out and having the opportunity to really take those type of baby steps in that direction?
It's a good question. I think one of the key elements to that is that it's iterative. You don't take one step at a time, you kind of do the steps many times. You start with a single case, like for example I showed for the pH meters, let's get those working, and then we envision the same things on the bigger stuff as well. And I talked to people here today who have similar experience from other fields, and they were so excited to try their models on our platform as well. So if we team up with other people here, I think those steps can come further and further, or at least faster and faster. And with more computational power as well, I don't know. They always say 10 years down the line, right? But let's say 5 in this case then.
And on that, so we also got a question online speaking about, so you talked about a lot about operation, in operation data we can take from that. But how about the steps before operation? Talking about planning and planning these projects, how can digital tools come into play, and how are we looking at that in terms of deployment and planning these projects?
That's a very good question, and I was a bit sorry to only talk about the operational settings here today because there's so much cool we can do in the design as well. I think there are two main cases. One is that, so when we build our capture plans, usually we take advantage of the MTU experiments that have tried in a certain industry or flue gas, but of course we haven't covered the whole industry, only some. We can use the data science to get more information about the things we haven't tried and make sure that when we build a capture plant for that particular industry, it's kind of data science proven. That's one thing. And also we have, the ACC proprietary solvents. They're very good, but we know that they have limitations as well. So we can envision using data science to make new solvents that are specific to that particular industry that will perform even better than our proprietary solvents, maybe sometime in the future.
And you talked about some of our partnerships. We have Cognite, of course, which is a central piece of this. We have our global partner, Microsoft, which is really important. How do you see the whole data science, open up for us with these type of highways that Azure and other, platforms provide, to everyone, suddenly connecting all of the businesses and all of the industries?
That's one of the best things in my job. There's so much excitement from these companies, and I think they kind of work at different levels. So Cognite at the moment is a very good partner in terms of the where we store our data coming from the different capture plans, good for analysis on the individual components. And then we have Microsoft, in which we're kind of working one step up to look at multiple capture plans, how this interacts with the rest of the world and those things. And there will be more actors coming on the road. For example, one might be a specialist in that type of pump and have a data science system for that. Some might say, oh, we actually have lots of chemists who want to help you with performing a data model for amine synthesis. So more and more actors are coming in, and the best part of them is that we can work together, all of them across. So it's a bright future down the road for data science in carbon capture.
Absolutely. So I, for those of you online that have been following Aker Carbon Capture for a while, with our global partnership with Microsoft, it's not just Microsoft, but we also now, of course, with Microsoft's keen interest in reducing their own footprint, have the collaboration with Ørsted, Microsoft and ACC, and developing these negative emissions as we speak. Very excited to talk more about that in a later one of our LinkedIn casts going forward. Seaman, I think you deserve to go out now and have some drinks with all of our customers and partners. Thank you very much for being with us.
And thank you very much to you too as well.
Absolutely. So we're going to have Ricardo join us now. Ricardo, one of our super specialists in the technology team, and we were super excited to hear about his experience. And I wanted you to maybe to start first, Ricardo, to take us a little bit back here in history, because you touched very briefly on it. You talked about in the infancy of, I would say, ACC in terms of the Solvit campaigns and all the good work is kind of the foundation for our company. Talk about how that has really affected how we look at solvents and the chemistry and the process.
Right. So is this thing on? I think it is. All right. Okay. So I think we started working with carbon capture way back in the 90s, the Snowvit. And then after that, we have been involved since 2008, 2009 in the large-scale projects in Norway. So Mongstad, for example, we were part of FEED study there, Carbon Center Mongstad. That was around the time that we were developing our solvents, developing our technology as well. And that was also around the time where the issue of emissions, the issue of the environmental impacts of carbon capture became more relevant, more important. So this has fed into our solvent development philosophy quite strongly. We have devoted a lot of effort during the Solvit program that you just mentioned to come up with a solution that would be stable solvent, a solvent that doesn't degrade, forming nitrosamines, doesn't affect the environment negatively.
And of course, this is a key thing that sometimes pops up in some of our market. How are we achieving to actually make use of some of the pushback we got from public perception in the early 2000s in Norway? And how are we educating others on the basis of what we did done?
Well, I mean, during the Solvit program that you just mentioned, maybe I can just talk briefly about what Solvit is. The Solvit program was an 8 years long program involving ACC, coordinated by ACC. Back then it was Aker.
Clean Carbon,
actually. Yeah. So it was the same abbreviation but a different name.
Yeah.
And we were developing solvents, developing technologies, but also investigating how to quantify all of these substances that would be harmful. Nitrosamines, nitramines, primary amines, secondary amines. So part of our education of the public came with that, how to identify these compounds and what is their impact to the environment. During that project as well, we have made studies about atmospheric reactions involving these nitrosamines, how they degrade in the atmosphere, or how they are formed in the atmosphere. We contributed with this archive of knowledge. We have developed in-house technologies to avoid aerosol emissions. Aerosol emissions were a big thing back then, are a big thing now as well, because with aerosol emissions, it doesn't matter if you have a solvent that is not volatile, you're going to pump up your solvent to the atmosphere anyhow. So that was an important development that we did and that we kept to ourselves. We were the first to use acid wash, to my knowledge, to avoid emissions of ammonia. So many small things that just build up to having a good environmental portfolio, and of course the solvent itself.
And just to take that, because we talk a lot about our solvent, but to many surprise might be that we actually have several solvents, don't we?
Yeah.
So could you elaborate a bit about, we have a library of solvents. What does that mean?
We have a library of solvents. During the Solvit program we investigated more than 90 compositions, different compositions. Of these 93 main solvents became our intellectual property, let's say, our arsenal to deal with carbon capture. One of them, can you mention them by name?
Yes.
Okay.
Well, at least our primary one, which
the S26.
I think we all know about it, and it's of course the core solvent that we
the
use.
S26 is our core solvent. It was developed in a way to avoid nitrosamine and emissions. So it's a non-volatile solvent. It consists only of primary amines, which is important because it's the secondary amines that form nitrosamines. It's stable, so it doesn't degrade into secondary products that form nitrosamines. Everything, every small detail of it. We did a series of biodegradation studies, a series of ecotoxicity studies. So it's a solvent whose main attractiveness is its lack of impact to health and environment. Of course, it's also energy efficient, blah, 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 but the main point of it is the agency profile.
And for those of you online, of course, with this portfolio of solvents, this enables us, of course, to offer large-scale carbon capture without those negative environmental challenges that we saw and which was addressed already in the early 2000s. Ricardo, thank you very much for joining us here in the after party. It's been remarkable to have you here. I can see now that we have Ryan coming into the picture, and before we let him in, we are going to continue now to have a talk with some of our excellent speakers. If you do want to learn more about carbon capture, do follow us on LinkedIn. We do regular LinkedIn broadcasts. But now, Ryan, you're here. You just took us through some of the groundbreaking, I would say, verified campaign, academically verified, and with record low heat numbers, which of course was one of the things that we have focused on today. You really, portrayed, some optimism at the end of this show, that these solutions are really fit for purpose, and especially now when it comes to blue hydrogen. Do you think blue hydrogen will actually take off in the end? Because there are, of course, with these, there are quite a bit of different opinions about, the various colors of hydrogen.
Well, John Christopher, thanks for that $1 million question.
And that's why we're here.
Good, putting me on the spot. Yeah. I think really what we're seeing right now, especially in Europe and with the new deal that Germany has done with Norway, and we're well positioned to hopefully benefit from that. We can see there's a drive and there's a momentum, and we had the partners earlier with MAN who really emphasized the role of hydrogen in the future, and especially in their vision. And if they decide that this is meaningful, it means that we need to consider it as well. And so definitely, if you would agree with me, I think there is no silver bullet in carbon capture, in renewable energy, and in hydrogen color. So I think we will need certainly all of them, and the size of the market is so big that considering that one of these colors will be out of the equation, probably a mistake.
And there are so many hectic people talking in the back, so I have to ask you to keep your microphone close to the...
Sorry.
So I'm getting that. But you talked about this specific campaign, and this was a really important milestone for ACC. What do you think, to summarize, what were the key things that we were left with, which now, of course, attracts a lot of interest in the market?
So I think one of the key things is that we demonstrated the technological viability of our solvent. One of our solvent in our portfolio that we decided to use for this flue gas. What we also demonstrated is that an open solvent, public solvent, might be tempting for a person who's not savvy of carbon capture and want an easy plant put together, but after just few hundred hours the solvent broke down in all sorts of ways, accumulating degradation product visibly with very high emissions, actually surprisingly high emissions, likely because of the oxygen content, but some of the details are discussed in the publication. I won't go into too much here. What it showed is, with several thousands of hours, our solvent was absolutely resilient and predictable as well in its energy performance, in its emission, and so that was a great learning, which again, as I said, puts us very confident when we say that blue hydrogen is one of our key markets.
And also too, for the viewers calling in here, when you talk about degradation products and the difference between our solvents and other solvents, could you, for anyone looking to install a CCS plant, what does it mean? What's the benefit of not having a degradation product in terms of the operability of the plant? What does this mean in terms of potential OPEX, maintenance? Could you share something about that?
Sure, absolutely. So when a solvent degrades, it also inherently loses its performances. So meaning that there are less amine available, reactive compound available to capture the CO2. That means that you can only continue capturing with the rate of capture you agreed on with the customer if you add some more new solvent. And that goes without saying, this is without talking about what goes in the air, which is for public solvent very unsettling amount. And so that's the kind of switch you have to do when you go from monoethanol amine to a proprietary solvent like one of ours. Also with regard to reclamation, as we saw after 500 hours of operation, it was definitely high time for several reclamation campaigns for the monoethanol amine. We operated several thousands of hours, actually never done a reclamation. So that says a lot because that costs as well.
Right, I think we're getting towards the end, and we, it's been a really nice day here in West Metal Bridge, where we've been looking at energy as a theme. Thank you, Ryan, for joining us in. And I can see that now our last commentator of today, our CTO, Jim Stian Olsen, is just entering the stage. Jim Stian, thanks for being with us here at the after party with our digital viewers. Yeah, so we're getting close to the end. Yes. What are your thoughts?
It's been a fantastic day. And it's so nice to be able to gather our technology experts in front of this kind of audience. That doesn't happen too often. Here we have the leaders of the industry, we have investors and so forth, and they get information about our technology in a fathomable way. You can actually understand what is being said, and I'm proud of the team, and I'm really happy about what we've been doing here today.
Yeah, because it's your team that's been presenting here today.
Absolutely, this is the core technology team. These are the guys who knows all the nitty-gritty details about our technology, and they've stepped up and presented it in this conference.
And I guess one of the key things that we get back as part of the commercial team is, of course, when we do our feasibility studies, it is actually Jim Stian's super experts that we borrow for a few months in order to look at these super cases. And I'm thinking, of course, we also need to do product development and next generation products. Is there something that you can tell us now after party wise? Is there what will the world look like? Will there be a new just catch? Will there be new ways of doing the big catch? How do you think the technology and products will develop?
Should we ask him after a couple of beers?
Probably. No, of course we will continue to develop our Just Catch products for sure. We have to make it more efficient and so forth. And we mentioned the energy saver today. This is something that was originally developed for large-scale plants, and now we're also deploying that for our Just Catch. So that becomes sort of a part of that product. So that's going to be good. We also are very cost conscious, so we are working to reduce cost also on our larger plants. So take some of the learnings we have from Just Catch and implement that on our larger plants as well, getting that standardization and modularization and efficient way of delivering projects rolled out there as well is going to be very important for us in the upcoming years and months.
And of course, we can't be here in London and not talk about UK. And we've heard some speculations. I think Emil touched upon that's going to be a very exciting year, 2023. Yeah. We have our big feeds ongoing here in the UK with Siemens Energy as the supplier of the gas turbine, together with Aker Solutions and Doosan. And we will see the results of these government funding mechanisms hopefully very soon. What are your thoughts? Any what is a gut feeling on this one?
Well, this is for us. It's very exciting projects. We are in essence developing what will be the world's largest capture plants if this comes into fruition. So We have 2 of these large feeds going on now, so I think we're well positioned in the UK Track 1 competition. And I'm really looking forward to the decisions coming up with the shortlisting and everything later this year. And I think we're going to see some exciting development in the UK market. And we also see a lot of traction from other customers in the UK as well, which presents some exciting opportunities for us.
And you talked about now the 2 major feeds that we're doing, where we get a lot of learnings on the gas to power market. How could that be a benefit for us going forward in other markets as well outside the UK?
Well, I think when we look at the American market as well, gas to power is going to be a very important part of that market. So I think we can bring all of those learnings into that once we start to explore more what our opportunities are there. And it's also, I think, as we mentioned today, we think fossil energy is going to be part of the energy mix also in Europe, I think, going forward. So I think we're going to see more projects in Europe with gas to power, and we'll of course take that learning with us in those other regions in Europe as well.
Yes, Stian, thank you very much. So, Emil, we are getting towards the end of the program and the after party here from Westminster. What are your thoughts?
Oh, it's been a fantastic day. So good energy in the room. It's been crowded for sure, overbooked I would say.
Absolutely.
And I think it's been what we can call overbooked online as well. So I'm happy with the attendance. I'm really happy with the presenters. I learned a lot.
Absolutely. And I think, you know, there were brilliant speeches. There were really nice partners here. We're looking forward to some of you joining us later. And going back to ACC's core value, you know, this is about working together. We're a company that only focuses on carbon capture. So every day, every meeting we have, every partner that we have is about trying to solve this bigger problem. It's about bold innovation. I think you heard it today. I think you heard Stian allude to some really technology innovations coming up, and it's about doing the right thing. And with that, I would like to thank all of you that are online for joining in today. It's been marvelous to have you here. We hope you enjoyed it. Keep on sending some of these questions online. We have a lot of questions now to answer over the next couple of hours. But from us, all of us, Emil and I, thank you very much.
Thank you.